Welcome to
And hello, everyone. I'm so happy to welcome you people who joined our opening ceremony today of our brilliant event of API Forum from Geekle. Thank you for joining us. Thank you for being interesting to this community. Thank you for paying attention to this idea and coming here because last days I feel like the world of software becomes more and more like I don't know, Lego toy, block toy, plastic one. I mean, we're more constructing different parts than just write it. So we decided to come together to find brilliant professionals and great people who could share about this specific trending important topic. And that's how like we came up with this idea, and I'm so happy you are here. I'm gonna share with you about like our upcoming events first because it's something really game changing happens on the market and everybody knows. And we talk about this chat GPT. Will some replace us or will not, or who will replace who, and all this stuff. But we're not going to discuss this topic today. But what I want to say is this summer is all about AI events at Geekle. We have several, starting from AI in web design on June 20th. Then we go to July 6th on AI in software development. Then we go to AI in QA, and then we finish up with, not finish up, no, then we just go to AI in marketing. This is something special. We do it for marketing people. It's really new for us because our usual audience is developers community. And then we are going to GPT coding for front-end developers and back-end developers. And I'm really excited about these two events because like no one can teach another how to code using ChatGPT, but people from our community reporting are significant results they can achieve using this powerful tool, not only with small modules or maybe improvements or testing or something, but they really code, they really develop, and they report really great stuff. And we're going to invite people who already have some experience and ideas how it works in their day-to-day life to share with the community. And I feel like the mission of Geekle is being changing now a little, because there are some people who already use AI instruments and tools. Some people are not, but we all understand that as soon as you start using these tools, the sooner you start, the better you'll be prepared for tomorrow, the more competitive you'll be tomorrow. So probably our mission now is to help our community, developers from our community, to jump into the stream and be prepared and equipped and get the best practices. So the last idea about this AI events is that we have prepared and going to launch GPT coding. We say this GPT coding labs. So we're gonna have laboratory for Python, laboratory for React, and other languages and technologies, where we'll come together. The stream will code using ChatGPT some tasks. We'll complete some stuff, and we'll try to take some even some environmental problems to solve or healthcare to solve, but using ChatGPT online in streams just to get an experience, just to use the collaborative collaborative power of a crowd and all together finding best solutions, because we really need to understand how to master the beast and make him serve us. So this is what we work on now, and what I personally really excited. But let's get back to this specific event API forum. I'm lucky to see about 1,200 registrations. And we also have, I'm excited that you're really interested in this topic, because it's really small segment. 18 speakers. We'll have day 1 and day 2, 3 blocks in each day. And we're gonna hear from our speakers about building API, building applications with API, of course, best practices and use cases. This is what Geekle about. We'll see how we deal with GraphQL, REST API, OpenAPI, Azure API, and others, and API management and everything. So many interesting topics. And I'm happy to invite Nick here. He always helps us with all this preparation of events and streams and everything. Hey, Nick, how are you?
Yeah, I'm doing great. Hello, everybody. So yeah, thank you, Ed, for this intro. I will add just a bit of information before we start. We have 3 more minutes. We have 2 days of the event. Hope you will be able to sit through most of it. We will have most of the speakers presenting live today. We'll have Q&A sessions, so people will be ready to answer your questions. Please write down any question that you might have. We're looking forward to having our speakers answer them. Of course, this will be recorded and available right where you watch this on our platform. So please come back here later and watch what you missed. You will find it right here, and we'll be publishing separate session videos. I already mentioned about the topics, so also feel free to, if you haven't already, go and check our agenda. It's on the left menu and top. There's a schedule link. Please check it out and find the topics that you definitely don't want to miss. Probably most of all of them, or most of them. So I want to also mention that I mentioned summer events, but I also had to add that this September we'll have a Go event. So this is the first event in this area that we decided to try doing an event about. So for the attendees of this event, we have a promo code API Geekle, and yeah, so this will be a cool event that we'll be talking about Go development, about latest practices, and we'll be hearing definitely for Google developer experts who are working with Go language. Definitely go check it out. The link will be and the promo code will be in the chat. And
cool, thank you. Yeah, go
so
on.
I see. Yeah, people, please keep writing in the chat. We always like to see everybody writing where are they watching this event from, and I think we have just 1 minute. We can.
Yeah, I just wanted to say thank you for everyone who joined this event, who took a part of preparation of it, and to our program committee members, to our speakers, to every attendee and everybody. And I'm so happy and excited. So let's waste no time and invite our first moderator here, and let's get it started.
Yeah, so I want to welcome to the stage David, who you will see presenting tomorrow. But for now, he'll be just a moderator. So let's welcome David. Hi.
Hi, how are you?
Doing great.
Thank you much for counting on me. I'm thrilled about this event.
Cool. Happy to see you. Happy to see you.
So let's not waste any time. The stage is yours, David. Please start the first block of today's event.
Yeah, let's do it.
Okay. Well, we are here in a talk with Bobur Umurzokov. He's a developer advocate, mentor, and speaker specialized in software engineering and leading developer audience. He has around 9 years of experience in IT. It's also a blogger about technology and the community around technology. He's going to talk about about how to build robust APIs, very focused in the API gateway. So he's here.
Welcome to my session on how to build robust APIs with API gateway. I'm super excited to be here and delivering this session at API Forum Conference. And today we're going to talk about how you can leverage API gateway to use some design patterns to make your API resilient. First of all, let me introduce myself. My name is Bobur. I'm a developer advocate for Apache API 6. And you can also reach out to me on these following social channels. I will be happy to answer your questions regarding my session. If you have a feedback, also all feedbacks are welcome about this session. So today's agenda looks like this. We start with giving this idea of what is the API gateway first, and I'm also talk about shortly one of the open source projects of API gateway like Apache API 6, and then also I will walk you through the resiliency design patterns, what kind of resilience design patterns we have with using API gateway, and also how you can build resilient applications by using API gateway's features and plugins. You're going to learn as well. And also I will learn and teach you like for the fault injection testing in the API gateway environment. At the end, you're going to have a demo for how you can enable health check endpoints and also how you can enable circuit breaker for your APIs. With that plan, let's get started. So APIs, just the 3 letters, right? By now, we are all familiar with this term because we are living increasingly API-centric world. Every service we use today either uses API or the API itself, right? Even ChatGPT uses API. If you take an example of OpenAI API, which also uses REST APIs to generate AI models and give a response. of generated AI models to the outside world. So here another question arises: how we can achieve the indicators or success of APIs when we say our API is successful. So there are some three indicators. We can say our API is successful by looking at how our APIs performing enough, or how our APIs is integrable, how you can integrate easily with other APIs and so on. And our API should be available 100% of the time, right? And how we can achieve this? There are a lot of ways in our modern life to make our API successful. One of the maybe options, the way of how we can achieve these indicators by using API gateway, right? I'm going to explain how and why we are using API gateway to make our APIs resilient in the upcoming slides. Let's assume that in this diagram, API gateway, because it stands in the middle of your system infrastructure, which receives some outcome, some requests from outside world, right? Because in the modern infrastructure, we usually build multiple microservices to consume or provide some application logic for our client application, right? We can have more than one microservice, and each microservice should have some URL passes to access, but it doesn't make sense to expose all the multiple URLs to the client applications, because client application need to map and should have a call this the backend applications APIs, right? Instead, we can use API gateway, which acts as a central point that routes incoming requests to the intended destinations. You can only give the client applications one URL path, and then you can access multiple services behind the scene. So this is how API gateway works in general. And next, like also you can use API gateway to observe your APIs, right? Because it also stays in the central, which is capable of knowing all the coming traffic, and it can also log the metrics. It can also analyze some traces by using third-party observability platforms like we know, for example, Prometheus. We know, for example, Grafana, if you're already using them. So by using these built-in connectors, you can easily ingest your metrics and logs into API gateway. So from the API gateway, you can learn how you are absorbing the data. This is actually one step to how you can build resilient applications, right? And API gateway can be further extended by using other set of plugins. Here, as you can see, like we can enable all the cross-cutting consoles by using other built-in plugins, like to handle authentication, traffic control, or transformation of your data. Or you can also make some security features available for your customers using these built-in plugins. When we talk about API gateways, there are some of them in the market. There are open source providers, enterprise, cloud version providers, but I'm going to also introduce you to today to Apache API 6. It is one of the fastest top growing project of Apache Software Foundation. Maybe you are already part of this community. If you are already contributing one of the Apache projects, open source projects, just raise your hand or leave in the chat your which project you are contributing to. And you can think of API 6 like Apache Kafka, Cassandra, right? Tomcat, quite famous the projects under ESF. And now API 6 also provides some API management features, like it has hot reloading plugin functionalities where you don't have to reload your server, stop and run again. If you want to enable any plugin, you can just configure, and in the run, this plugin will be available. And other features I really like, for example, sometimes your requirements is high and the current existing built-in plugins might be not enough to meet your requirements, right, or business need. In this case, you can write your own custom plugin by using your favorite programming language, or you are quite flexible with. For example, if you're a Java developer, you can use API 6 Java plugin runner to create your own plugin, right, to make a extended traffic control and for your clients' app data. Or you can use Python, JavaScript, or Go. Another feature I also like, it's plugin orchestration, where you can use open source, free dashboard. On the UI, you can just drag and drop existing plugins to build new plugins together. You can, for example, compose one plugin or multiple plugins to create your own plugin and put some conditions between, like one plugin, if gives output, it will be input to another plugin. I also highly recommend you can check the website and have a try to use this dashboard. It's a quite interesting dashboard. So let's talk about now how we can make our resident APIs. First of all, to make resident APIs, we need to use some resiliency design patterns. Because resiliency is ability to recover from failures and continue to be functional, right? It isn't
Okay, folks, I'm sorry. We are experiencing small issues. We will reload the video and play it. Sorry, bear with us for a minute.
now how we can make our resident APIs. First of all, to make resident APIs, we need to use some resiliency design patterns. Because resiliency is ability to recover from failures and continue to be functional, right? It isn't about avoiding failures, but accepting the fact that failures will happen and responding to them in a way that avoids a downstream or data loss. The goal of resiliency is to return application to functioning state after such as failures. So, for example, you can use rate limiting, one of the design patterns. As the name suggests, it limits the number of requests that can be made to your API over a period of time, right? Use of rate limiting typically refers to rejecting traffic based on the properties of individual requests, like maybe too many from given users or client application by the location. In this case, API Gateway provides out-of-the-box rate limiting features by using its plugins. You can just put this plugin in the middle to limit some API requests. Or next design pattern, like load shedding, which refers to rejecting requests actually based on the overall state of your system, your backend system, or let's say database. Maybe database at heavy load and no more worker threads available in your backend. In this case, API Gateway can also be a central point where it can check regularly this backend service, in our case attendee service, if it is available, by sending some health check endpoint requests, right? It's actually a quite commonly used feature. Or you can also enable features like timeout or fallback. In this case, if your upstream service or backend service, attendee service cannot respond on time, we can also set some timeouts until API Gateway can wait our request to be served. Otherwise, it can fall back to some default response. In our case, we can use API Gateway's caches, where you can cache a response beforehand to handle this sort of failures, right? And the next one, for example, you can also use is redundant instances. For example, you can have a multiple instance of single attendee service, let's say attendee service A and attendee service B. In this case, if the API gateway cannot get the output response within this time period, like in 10 seconds, from the service A, it can always get the content from service B. This actually, the future also use it broadly when you're making new releases, like we call it canary release, or when you are making A/B testing, where you can send the traffic partially to one service and partially to another service to test fully your new feature in the prod. Next is well commonly known as health checker APIs, where API 6 also capable of checking the health of your APIs by periodically requesting this health API endpoint exposed by your target backend service to identify if this attendee service is available to serve your request. Or if it's not available, it can also capable of retrying to send the same request multiple times. You can specify how many times API gateway should request by sending HTTP request to the attendee service, and also you can specify some timeouts and duration of these calls. Yeah, it sounds good, right? And then I really like another feature is circuit breaker. It's also commonly known when you're building robust APIs. For example, API 6 or most all modern API gateway provide a special API breaker plugin that implements this user circuit breaker functionality to make this handle features, to handle the failures and prevent the upstream services from constant retry attempts, because sometimes you don't want to retry continuously, right? If the service fails, performs slowly, we can just simply return the response immediately, because API gateway can monitor the number of failures that have occurred so far and use this information to decide whether to allow or not this operation to proceed to your backend service. Otherwise, it responds immediately with an error to your client application. So another great feature I like is fault injection approach at the API gateway level. It can be used to test your resiliency of your application or microservices against various forms of failures. Let's say if you want to build a confidence in the production environment, right? You can inject some delays. Also, you can put some aborts with user-specified error codes, and you can also mock the response data to stage different failure scenarios, such as service failures, service overloads, high network latency, or network partitioning, and so on. For example, you can use the fault injection plugin of API 6 to simulate this sort of errors. Like you can simulate the delays by putting some network latency. If microservice A and B are talking to each other, you can say, hey, B is not working, how we can test A respond to the client application. In this case, let's suppose if we have online shopping sample application with many microservices, right? Like a catalog, product, order, right? When we are retrieving data, for example, about products belonging to the specific catalog, there will be service-to-service interaction, which means that something can go wrong, right? With catalog and product service. So with that in mind, I can demo to you one simple scenario how we can analyze if product service failure and then catalog service, how it can act by enabling fault injection testing. Simply, fault injection is the ability to test the resiliency of your application. To enable this plugin, you can go to Apache API 6 official website. You can find under plugin session fault injection testing. It's called that. So, and then you can also find out my repository where I provide with API 6 some samples where I test .NET ASP application API with against various failures. For example, you can find open this project with your favorite editor and then introduce this fault injection plugins under config YAML file of API 6. So you can start to work with these new plugin, and I'm running my application with Docker Compose. I will do just Docker Compose app to bring my unnecessary containers. In my case, I'm using Windows machine, desktop, Docker desktop application installed, and then as you can see, 6 containers are up and running. One container for Grafana, one container for Prometheus if you want to use observability features, and product API with a single endpoint. You can also have a look on the GitHub repository how this endpoint works. It just simply responds product lists when you're requesting. Let's start with first using fault injection plugin. We are going to introduce some delays in the response. I want to introduce to product API as my backend because I'm also configuring my backend service on the upstream object. If you want to configure anything with API 6, you need to use admin API of Apache API 6. In this case, I'm introducing some delays with duration 5 seconds for my product API. If I'm trying to now call product API / products with my introduced delay, as you can see, I am actually, my request is delayed, or my response is delayed. You see, I'm waiting for 5 seconds to get my response from there. So that's how delays works. Next, for example, we can test with aborts. Like we can try to simulate how we can abort some requests coming to the product API. And to do so, I need to replace delay the object with abort object and say what kind of HTTP stats I want to return immediately. Let's say by saying the product service is currently unavailable, for example, and then ask admin API to configure this functionality. And then if I try to now request /API /products, I should get rejection immediately because which just simulates behavior of products APIs, right? As you can see, it's saying the product service is currently unavailable. That's how the fault injection works. It's a quite good, helpful feature for especially not only for developers, also QA engineers. I know something can be not clear yet. I'm trying to now slow down and then I'm trying to explain step by step how we can achieve this fault injection. Before achieving fault injection, we need to, of course, install API 6, start with building our resilient APIs, enabling retry mechanism, timeout, health check, and circuit breaker, right? To do so, I prepared already for you a demo session. You can find it under my GitHub repository called API6.NET Docker. Why we are calling this name? Because I'm going to test one single endpoint exposed by my ESP.NET application using .NET 6. You can also find out the tutorial step-by-step explanation how you can run API 6 under this link, or by reading. You can have a try after this session. So typically, I'm going to demonstrate how you can manage .NET microservice. It can be any microservice or API built using any programming language. In this case, Python. You can use Java using Spring Framework, right? So, and here you can also find what other prerequisites to run this sample. And we are using simply Docker Compose, so you can do Docker Compose app to bring all the necessary containers as we bring it out previously, right? And then actually this backend service we are going to test is simply /API /products exposed on the local host 5555. And also we're gonna first enable this routing mechanism by using API 6, and then we can try to, for example, enable some other functionalities like, for example, we can enable API breaker plugin or introduce some API consumers if you want to make an authentication-based API calls to your product API. So let's jump back to my editor, and I'm going to explain step by step how you can configure API 6 to your backend API. If you open the project with your favorite editor, in my case VS Code, right? and you can find under commands folder all the example commands, kernel commands we're going to use for this demo. Under examples, also you can see different scenarios, how you can enable circuit breaker or fault injection, health check. If you cannot find this example, you can navigate to another branch from main or master. You can check out API fault handling branch. So first, we need to always enable, let's say, and use API 6. We need to run. As you can see, the API 6 is up and running with the Docker Compose. I can see some logs coming from the Docker. So with that, everything is good. First step, I'm going to create upstream object using API 6. Upstream objects acts as our backend server. How we can have a multiple backend services or single backend service. By using admin API of API 6, we can manage the API gateway configurations. Like I can create upstream, route, I can enable the plugins and so on. In my case, as you can see, I'm creating a new upstream and I have only a single node for the product API, which is exposed to the 80 the port. Like I can access my product API, it responds me the response by returning list of the products. So first thing, I need to run the create upstream curl command. You can also use Postman to achieve the same instead of using CLI to run these curl commands. First step, I created my upstream for my API gateway, in my case product API, right? And next, I'm going to enable the API breaker plugin. To do so, I need to create another API 6 object called route. Route acts as a mechanism to provide some rules and policies how we can route to the backend service from the API gateway. You can, in this case, you have full control of all the incoming requests from your clients, right? For example, I can specify the methods, what kind of methods I should match if the request coming to different URL endpoints, right? In my case, I need to listen to /API/products. As soon as I get request to this endpoint, I'm gonna forward this request to the upstream service. But before forwarding them, I need to enable some features like API breaking features. Let me explain it. Under routes, you can also specify a list of plugins you want to use to manage your traffic, enable authentication, or security features. In my case, I am enabling API breaker plugin using API breaker of API 6. In this plugin configuration, I am asking API 6 to enable circuit breaker policy to configure so that it breaks an open circuit when there have been 3 consecutive faults. Like in my case, if I get from a healthy endpoint 500 or 503 error after the requesting 3 times by sending HTTP request to this backend service, when that happens, upstream service move to unhealthy state and the circuit breaker and waits for 30 seconds, as you can see. In that period, calls will be failed immediately by the API breaker because we are under unhealthy the period, right? Any single HTTP response code, if we get as a success, in our case 200, will restore again this backend service to healthy status. So first thing first, once we clear how API breaker works, how API breaker actually pattern works, it's defined similarly in API breaker plugin, and I can try to run this curl command and API 6 response okay. And how we can validate actually this API breaker works. It's very, very straightforward. You can validate this scenario. One of the stupid options can be just by stopping product API, for example. You can just stop the product API here from the container of Docker, which counts 503 service temporary unavailable error. We can see the API breaker takes the control. Or another option, you can update the code under actually backend service by navigating to product API or controllers. You can here put some exception, which returns 500, like internal server error. So let's try to put some exception to my product API and then test how API gateway reacts in this situation. Once if you run this application again with this new change, this throws exception and try to access your product API, you're gonna get immediately internal server error, or because the API gateway is responding before reaching our request to backend service, responding immediately from the API gateway, right? So of course, you can also customize this message by saying or another error message or responding maybe not 500, another HTTP status by configuring API gateway. That's how API gateway can handle the API breaker functionality, right? And the last thing I'm going to also explain how you can achieve creating upstream routes and also enabling this timeout, retry, circuit breaker, health checks on the dashboard. To do so, if you navigate to API 6 dashboard, it's running on the 9000 API port. As you can see, I have a dashboard is running. It's also a community dashboard. It's for free. You can also use dashboard to create easily your routes and upstreams. As you can see, actually this is under route, this dashboard, I can see my route we created using curl command. Or if you navigate upstream, you can see it's loading a little bit. If you can see the upstream we created previously with some functionalities and so on. Here, for example, you can enable some retries or timeouts or send or read timeouts and so on, a lot of capabilities. You can also enable health checks here, specify some rules for your health checks, or there's also called passive health check to enable circuit breaker functionalities. Or if you want to have multiple instances of single service, you can add here the second service. If one service not responding API 6, always can fall back to another service by setting some weight for your services. As a takeaways from this session, you can always try to use resilience design patterns for your APIs to build robust APIs. And you can use API gateway because API gateway already has these features out of the box. You don't have to implement yourself something big, right? Or the build will from scratch. And also you can test this resiliency of your APIs by using fault injection testing mechanism, or you can simply use some API management solutions to efficiently observe your APIs by adding metrics, logs, and traces, and so on. I hope this session was helpful for you. If you want to learn more about API 6, you can check out the references, join our Slack community, and ask questions. We have a very active community who is ready to answer your questions. Or if you have any questions now, please leave out in the chat session. Thank you for attending my session. So see you soon.
Thank you very much for your talk. Okay, we are back with another amazing talk supported by Ankit Mahato. Ankit is an architect open source evangelist, so we are at the same page, and the founder of FOSS42, an organization that builds free and open source API and developer tools. Ankit has more than 10 years of enterprise software development experience and has led product both at UAs as a SaaS company, where he built and deployed cutting-edge machine learning solutions in Nielsen, some banks, and other relevant companies. He has also delivered more than 20 talks on workshop about ML and data science. And yeah, I'm going to give him warmly come back. Welcome. How are you?
Welcome.
Oh. I'm afraid that we have lost him. Probably he clicked not the right button. Let's see if we can. Okay, back here. Hello.
Yes. Sorry.
Back once again.
Back once again. Yeah.
Okay, no worries.
Welcome everyone. So can you share? Yeah. So I've just shared my screen. Yeah. So just to begin with, in case you have any questions or any other issues regarding ML, any programming language, you can just check out the Discord server. I'll answer it post this session. If you have any question, you can also post it there. So I'm just sharing the links in case anyone wants to connect with me or join the Discord server. So yeah, so let's begin. So hi, I'm Ankit. I'm the founder of API Dash. Previously, I worked in JP Morgan and I was also working in a US startup. So just to give you a brief, API Dash is basically an API client geared towards multimedia and ML APIs. So you can preview responses, you can download preview multimedia APIs, and you can generate integration code. So now let's get started with the topic. So what is machine learning? We all know, we have heard this term machine learning. So what is it? So basically, if we go back, the earlier we used to do classical programming. In classical programming, we had some rules that we used to come up with that, okay, for these conditions, this should happen. And then we have the data. So we combine the rules and the data and we got our answers. So machine learning changed everything. So what happened now? A company started collecting tons of data. So we have data, we have answers. We also have the corresponding answers, whether or not, for example, a particular email, whether or not it is a spam, or whether or not a person gets a loan based on his profile. So we have the data and we have the answers. Now we are trying to we are trying to figure out what is the algorithm to actually determine that, okay, for a new data, this should be the predicted answer. So this is what machine learning is. You have the data, you have answers, and you try to build the rules. The algorithms, the machine learning algorithms help you figure out what are the rules. Now, coming to next part. Now, what is machine learning API? So API is basically this rules that you figured out. You bundle these rules. It's called a model, machine learning model, and it is since you have already trained it, so it's called a trained models. You bundle together these algorithms, you put it in a cloud, and you just give access to that algorithm via an API, and now you can just use any front end framework or anything, mobile app, anywhere. You can just fit in new data and you can get some predictions out of it. So this is what a machine learning API is. It allows you to actually use pre-trained models, which is residing in the cloud, to via REST API. You can just pass on the new data, and you can, as a response to that API request, you get the predicted results. And believe me, it is here, there, and everywhere. Everyone is using APIs nowadays. apps are getting more and more API centric. Companies are depending on APIs a lot. So, and machine learning APIs are also everywhere. Be it be it transportation sector, you have APIs to actually a very simple example, APIs to determine what is the best route you will take to reach from point A to point B. So that's the most basic thing. Then you have other kinds of APIs to detect basically long range sensors, data, analyze these things. So it is prominent in transportation sector. In healthcare sector, you have APIs to determine how good you are sleeping, and also if there is any issue, any health issue there. So in healthcare sector also there are machine learning APIs in use. In manufacturing, machine learning APIs are used to detect whether or not basically a manufactured part, whether or not it passes the qualification criteria, or for example, whether or not a particular based on this computer vision and machine learning, you can actually determine whether or not the shop floor has been proper safety is being followed on the shop floor. So it is, APIs are now being used everywhere, and machine learning APIs are also kind of everywhere. So, and as ML is evolving over time, this is a very famous graph. You can see how it evolved from artificial intelligence to machine learning, and now deep learning, ChatGPT and LLMs being the most recent example of APIs. So, as ML is evolving with time, so are ML APIs. So nowadays you have basically a lot of high-end APIs for LLMs and for machine learning, and you might be thinking, why not build something on my own? So, and the question that comes in mind, where should I begin? So the thing is, with ChatGPT, you are be like, okay, I'll directly jump into building a ChatGPT API, an alternative to it. But you have to remember that there is a cost for building a deep learning API. So it is a deep learning API. So there is a cost for building it. For example, you need tons of data. So only then the model will perform very well. So deep learning models scale with data. The more data you have, the better models you can get. Also, you have to remember these models are very difficult to train, and so there is an basically training epoch, and and there are times that it might be months and the model will not converge. So this is, you have to also have a lot of patience when you are building a deep learning API. Also the question is, how will you interpret the model? So this is one of the challenges. So the result that you get, how do you interpret it? So that is another challenge. It is kind of a black box. Also the computing power, you need tons of GPUs to train deep learning models. You have to also take that into account. So there is hardware requirements. So if you have all these means and you can actually go ahead and build it, it is really good way to go ahead. But if you have limited resources and you want to learn how to build machine learning APIs, you should start with the basics. So what is basic? So let me tell you the entire process of an ML API, entire life cycle of an ML API. So, so it all happens with the first step, which is when you identify a problem. So before you just go ahead and build an ML API, you have to build a model. And to build a model, you need to actually figure out a problem that your model or your API is going to solve. So the first step is to identify the problem. Then you need to access the data. For example, the data can reside in a file. It can reside in a CSV form. It might be available on the internet, which you can fetch via web scraping, or even there are a lot of data APIs that you can access to get that kind of data. Also, it can reside in a database. It can be a NoSQL database, SQL database. So then you have to figure out how to access the data. Again, remember, it is the raw data. So you need to figure out a way to just access the raw data. Then comes the step when you are exploring the data. So by exploring, I mean you try to build some kind of visualization, or you can do some on a single variable, you can do histogram analysis. uh, so these kind of the heat map analysis on a variable. So this kind of gives you a rounded picture, a very basic picture of how the data looks like. You can see whether or not there are certain outliers, or whether or not basically uh, how well the data looks. That's the whole point of data exploration. The next part is actually now you start working on the data. So the next part is to filter out the data and transform the data. So by filtering, I mean there might be some missing data, and you might want to filter those rows. Now now you will go ahead and basically skip those rows, and also might be that for certain conditions for a particular field, you don't want that kind of data, so you will go ahead and filter it. Also, you can you can remove certain columns that you think that is not required, because there are a lot of columns which are filled with metadata, which you do not require to actually build the model. So you will go ahead and filter out those columns, and then you will have to transform the data. By transformation, I mean data can be in form of categorical variables, like whether a person is single, whether he's married. So that kind of data set, it is categorical in nature. You need to assign a categorical code to it. For example, for single it will be 0, for married it might be 1, and similar for other cases. So you need to transform categorical variables to basically numerical form, and you might want to basically scale a particular field. So for example, if there is a column with a data which is like spreads from 0 to like a million, you might want to scale that in the normal distribution form. So you will go ahead and apply the transformations to actually scale the data. So these kinds of after you go ahead and scale the data, you do filter the data, and you do all sorts of transformation. Now you are ready with the data to build a model. So then you can go ahead and build a model now based on basically what is the requirement, as in whether or not whether it is a supervised learning or a unsupervised learning method. So you will go ahead and build or whether you want to use neural networks, various algorithms for supervised learning, like you want to build a KNN model, or you want to build a random forest model. So so there are various types of models. You need to figure out what is the way to go ahead, and for that you start building the model. So you apply different algorithms, and you see what kind of results it get. Now this is not an intuitive process, like you don't know actually that okay, this model is better than this, unless and until you evaluate the model. So once you fit in various models, build various models of basically using different algorithms, you now go ahead and evaluate these models. So there are multiple methods to actually, very basic thing is a confusion matrix, where you see what is the accuracy, precision. And then there is ROC analysis, where you see the area under the ROC curve. The larger the area, the better the model. Or you can do cross validation. So there is a method called a scaffold cross validation, where you divide the data in basically 10 parts, and take one part for actually testing and the remaining 9 for training. And then you repeat the process for all the parts, and then you take out an average R squared. So that kind of gives you a picture that okay, which model is performing well after cross validation. It removes a lot of biases. So that is so after you evaluate the model, now you are ready that okay, now my model is built. It has a certain accuracy. It can be more than 90%. It can be more than 70%. So I have that accurate model with me. Now let's go ahead and deploy it, build an API out of it. So then comes the main question: how are you going to export the model? So there are various formats for deep learning models. There are people directly deploy TensorFlow models, or they export it in the ONNX format, ONNX format. And for a traditional model like what we build using a scikit-learn, you can actually dump it as a pickle. You can actually dump it as a joblib. Uh, so that kind of thing is there. So the you need to decide how are you going to export a model. For our programming language, our models, the process is different. It's RDA format. So various frameworks, they have various formats to save the model. Then you go ahead and deploy it. By deploying means you design. So you first, what are the model? What are the model variables that are required? You define those variables. Now, how are you going to get that kind of fetch those variables? The kind of API that you are going to use, that you have to decide that whether it will be a GET request, whether it will be a POST request. In POST, the user has to supply a JSON with all the variable fields and the corresponding values. If it is a GET, then it is a simple GET. Then user can specify it in the as query parameters. So you need to design the API interface, as in how the user will interact with your model. So you need to design that, and then the next step is actually go ahead and deploying it in the cloud server. And there you can use frameworks like Fast API, Flask. You can use those, even Django REST. So you can use these frameworks to actually expose your model in the form of a REST API. And then comes the next step where you monitor the results. What you can do is you can log the API usage. You can also collect the new data that you are receiving at your end, and and analyze it whether or not the model is performing well with the new set of data that is arriving. And then what happens is, suppose you come up with the next iteration of model, then without which might require more parameters or less parameters. So the API might specification might change. So what you do API versioning, where like you expose kind of latest people can specify whether in the headers whether they want the v3 model or v2 model. By default, it will always call the latest model. So that kind of API versioning you need to do. And then the next step is basically once again identifying the problem. So why I am saying why is it a cycle? Let me give you a very good example for it. So there's a company which built API where you can take the photograph of your license plate, and then you can, what you can do is you can upload it. And after uploading, you can actually get it will run the API, it will run the model, and it will fetch, or it will read it will provide the numbers, the number plate, license plate numbers to the user as a result. Now what happened, this was the problem that the company identified, and they went ahead and solved it and deployed the model, gave users an API. Now what happened, after a month, a couple of months, they went back to look at the data that they had logged, what the users were data that users were providing from their end, to see what is the usage, what kind of to get a basically understand how users are interacting with their APIs. And then they uncovered that users were actually using it for OCR. And then they identified, okay, then this is a problem, because users want OCR APIs to actually go ahead and process documents and get the text from it. So then they identified a new problem that, okay, let us make our model good for OCR. And then they started the entire process. So this is a real life example that how companies, they built APIs, exposed it, and then they actually went ahead and identified a new problem, and then they restarted the entire cycle. So now moving ahead. So today, let us focus on this part, that is model export and deploying the model. So the thing is, in various companies, there are developers who are like proficient in various frameworks. So some might be proficient in R, some might be proficient in TensorFlow, some proficient in PyTorch. So the thing is that since they are proficient in these frameworks, uh, developers tend to use those frameworks, develop models. Now, what happens is, for a company, it becomes a challenge that, okay, a person is providing you a model built in PyTorch. Person is providing you the model exported as TensorFlow, TF-Lite. So the thing happens is then as a DevOps person, you are challenged, because now how will you deploy these API, these models? So the thing is, that's where the whole microservices and serverless frameworks come into the picture. So what you can do is actually developers, where we are heading is in terms of APIs, developers use the frameworks of their choice. They export the model in the format of the particular framework, and then they spin up a microservice, they spin up a container where which will expose that model as an API. Otherwise, another case is where you can actually go ahead and deploy it on a serverless framework. You can expose it as a Lambda or a Google Cloud via Google App Engine, so which will automatically scale based on the usage of APIs. So these are the two, instead of monoliths, these are the two popular architectures that people are actually using to go ahead and deploy ML APIs. So let us take an example where we will do a real estate evaluation. And in this example, I'm using pandas to read the CSV file and perform transformations. I'm using scikit-learn, a basic scikit-learn, to actually go ahead and build a linear regression model. So these are the basically classes that I'm importing. And next part is there. I have a data set where we have variables like the age of the house, the distance from the MRT station, the number of convenience stores, latitude, longitude, and the house price of the unit area. So what we need to do is these x's like house age, distance from the nearest station, convenience stores, latitude, longitude. These are the variables on which we are going to build a model and predict that, okay, what will be the corresponding house price. So first we need to do is scale the data, scale the fields. So what we'll do, we'll call a standard scaler. We will do scalar.fit transform. It will scale the numbers. You can see the column values have been scaled now. So now basically what it helps is it helps in the convergence of the model. And you can see that in one X, that is basically the array of all the independent variables. This is basically the X, and the Y is basically the one which we are going to predict. Right now it is given for this, but we are going to predict it for the new data. So then we do training and testing split. So 20% we'll use for testing. For training, we'll use remaining 80%. So you can see the train test split. It is 331 rows of data in training and 83 in testing. Now we will use the linear regression class. We will create an object, and we will fit the training and the corresponding Y train. We will fit and build a model. Now you can see that model underscore reg coef is the coefficient of linear basically linear regression model. So it is y equal to mx plus c. So this coefficient is basically m, and model and intercept is actually the c part. So we now have m and we have c. Now for a new x, we can find the corresponding the corresponding y. And then we will score. So the model that we train, now let us go ahead and score it. Let us see how good it is. So the goodness of fit is calculated using R-square method, and it is like the coefficient, and it is also known as coefficient of determination. We are going to fit our testing data set and see how good the model is. And you can see we got an accuracy of 70%. So it was 0.7. So for one, it is a really good fit. 0 is not good fit. So you have to see how is the goodness of fit. Now the thing over here is, now what the problem is, how are we going to export the model and how are we going to deploy it? So scikit-learn provides you with a feature called as pipeline. So in pipeline, you define all the steps. For example, in the steps is basically the first step is to scale the data, and the next step is to build the model. So you define all the steps as an basically you pass a array, a list of these steps, and you fit the model. So pipe.fit fits the model, and what you get is actually this is actually a representation of all the steps that are happening. Then again, when you score the testing data set that we separated, you score it, and you will get the same result. You can see it is 0.7007. It is same as what we got previously. So you can see the model building part is going well. Now, the best part about pipeline is you can dump the entire pipeline into a model file. So you can use joblib to dump it into a model file, and then you can take this model anywhere and deploy in the cloud. And if you have a Python environment, you can go ahead and actually run it. So what we will do, we will use the App Engine. App Engine is a serverless facility provided by GCP. We can use that. For example, in the app, so this is the folder structure. So you have the requirements.txt file, the app.yaml file, which defines that how the runtime that the app is going to use, and what will be the entry point. Entry point is basically how it will run the code. And the main.py file will contain the code that we will see. And the model.joblib is the model that we we actually built and we exported it. Now, in the app.yaml file, you can see the runtime that I have selected is Python 3.11. And the entry point is basically, it is how we are going to run the main.py file. So we are using fast API. So we will use gunicorn. Worker 4 is basically 4 nodes. And we will actually fire up the app. The requirements is fast API, gunicorn, uvicorn, and joblib. So this is the fast API code. So you can see how we define an app. Then you can see the the model we have loaded. We have loaded the model. Model is equal to joblib.load model.joblib file, and app.get actually gets you basically is how you define the API interface. So app.get, and within brackets, if you have just a single slash, it is the entry point. Like for example, api.fos42.com. It will give you this result, which is hello scoring API. Now, app.post predict is basically, it will use that the user has to use the post method, and predict is the endpoint. So it will be like something like api.fos42.com/predict, and you send a post request. Post request with a body, with a JSON body containing params like houses, distance MRT, store, latitude, and longitude. Users can provide it via post body, and this will automatically be read by our app. You can see we are using Pydantic to actually understand the data and parse it, and also for checking purposes, people use Pydantic. Now once you have all these parameters, these were the variables. This is the new data set that is coming in. We can go ahead and predict the corresponding result, and we can return the prediction. So you can see how we built an actual API. We exposed our model via an API using fast API. So so this is the end. In case you have any questions, feel free to shoot. Feel free to connect with me. Also, I've shared all the links. So any questions, please feel free to ask.
Okay, thank you very much for being here. Very nice talk. Congratulations. I think that we are also on the same page. I like very much your talk. Thank you.
Thank you, David.
Okay, let's go with the next talk, entitled "Evolving Your APIs: A Pragmatic Approach" by Nicolas Fränkel. Welcome here.
Hello. Thanks. That was actually supposed to be a pre-recorded talk. I will do Q live.
Okay. Sorry then.
Hi, folks.
This one.
Thanks to be here for this talk about evolving your API, a step-by-step approach. I'm Nicolas Fränkel. I've been working in IT for more than 20 years now. I held a lot of different technical roles, from developer to solution architects. And since a couple of years, I decided to switch to developer advocacy, though I think I'm still a developer. Regarding this talk, you probably are interested in APIs because you actually had to develop one. And the first time or the first couple of times, you are very focused on very specific things like modeling the right entities or trying to understand what is REST, what is RESTful, and reading Roy Fielding's writing and everything that has been written on REST before. Just a note, I will use the term API for HTTP APIs, and I won't delve into the specifics of REST because there is a lot of debate. So just to be clear, it's not about REST. You can use this talk regardless whether you have been doing REST or not. Anyway, so you were focused on those topics, and on top of that, you had a project with a deadline, and you didn't think about some stuff that was not very important at the time. But when your business comes to you and say, hey, we want to write a V2, then it becomes important. How do you manage to evolve from V1 to V2? And if you didn't plan ahead, you probably have this kind of reaction. So my idea in this talk is to give you a couple of tips and tricks so that when you write a V1 and your business comes to write to ask you to evolve to a V2, you don't have this kind of reaction and you can handle it more peacefully. So this is probably your initial situation. You have an upstream. Here I'm using the word upstream for reason that I will explain later. You can think about as an upstream as a regular web app or application or whatever. And you have a couple of endpoints that you expose over the internet. And I'm telling you, hey, everything will be solved if you put an API gateway between your upstream and your clients. That's easy. Sounds too good to be true, especially since now you realize that you probably already have something that sits in between, and that something is called the reverse proxy. And I'm telling you, no, you should use an API gateway. So before I delve into how, let me give you the reason why an API gateway can help and why it's different from a reverse proxy. For that, we need to go back a bit. So as I mentioned, I've been working in IT for a long time, but before even I worked in IT, I created my internet website. I started to use the internet before 2000, which is for most of you probably very, very long. So my first website, at the time we had HTML, and I learned HTML not by reading books about HTML. There was no Google search at the time. There was no Google. Google just started just a bit afterwards, or at least I came to know it a bit after I started. I browsed directories, Alta Vista at the time. So I learned HTML by reading the web page, by looking at the source itself. We already had images. That was nice. We had a lot of images to make it look much, much nicer. We also had audio file, MIDI audio file. So every time you browse the website, You could like play this MIDI file. It was automated. You couldn't stop it. That was horrible user experience, but of course we did it because we could. There was no CSS, so to create your buttons, you had this bevel effect with table, really great developer experience, and I let you to judge whether no JavaScript was a good or bad idea. Anyway, that's how we managed. At the time, I didn't think about it, but there was a web server. And the web server, in this case, was made to serve static content. So HTML pages, images, MIDI files, everything was static. But some people decided it was not enough. We wanted to have dynamic content. Of course, we wanted to have dynamic content to display the date and the time, which was completely useless. Again, horrible user experience. But sometimes you wanted to do like real interesting stuff, like a last updated timestamp, which was useful to you. You could see that the page hadn't been updated in ages, or it was very fresh. And we started with Perl scripts because Perl was available on many Linux systems at the time. The problem with Perl is, well, first you had to know Perl, and then you had to like write something in Perl to generate something in HTML, which was not that great regarding maintenance. So somebody decided, hey, we can do better. Perhaps we can write HTML and add a couple of tags. And when the server serves the page, it just like outputs the regular static content. And when there is these special tags, then it calls some routine. And it was the beginning of PHP, personal homepage. And that was really, really great. Everybody was happy. And it was so great that actually the World Wide Web starting to see an increase. Companies, not regular people doing their own personal website, regular companies wanted to have their own website to look good, to have another channel of communication with their customers. And as a personal user, if your site is down, that's not great, but you can survive. If you are a company, you want your image to be spotless. So you want your site to be up all the time. And that's when the web server started to have different features, not only serve static content or dynamic content, but we had another row of web server in front to do some redundancy. Like, for example, for load balancing, if a node was down, we would direct it to a node that was up. And of course, the web grew and grew. And before you had a couple of nodes serving contents, and the content was all the same. But now we had extranet and intranet and internet. So all the nodes were not similar anymore. So these another layer of web server, they had also to do routing, saying, oh, okay, this person wants to access the extranet is on those two nodes, so I will direct it to one of those two nodes and not to the other nodes that serve, I don't know, the internet. And so that's the evolution of the web server. To serve static content, then to serve dynamic content, then to do load balancing, then to do routing. And actually, this layer of web server, this front layer, is known as a reverse proxy. It becomes the single point of entry to do everything. And once, as an architect, you see a single point of entry, you start to push additional capabilities. You can have authentication, you can have caching, you can have rate limiting, you can have lots of different capabilities because you have a single entry point. On another side, we also started to exchange data. So at the beginning, to exchange data with another company, we sent a file through FTP on the other side, there was a bad job watching the folder, and every hour or every day or every time, it would like check the contents of the folder, would like manage the content of the file, and then rename the file to done, for example. That's good when it's asynchronous, but when you want to have synchronous communication, you need to find another way. And the problem is that companies might and probably have different tech stacks. So you cannot rely on Java or .NET or whatever specific protocols. And the only brick that is available across all tech stacks is HTTP. So that's the reason for APIs. We want to exchange data in a format that is available to all tech stacks. And that's where comes the difference with reverse proxy. An API gateway is a specialized reverse proxy. It should be able to do everything a reverse proxy is able to do, but with dedicated features only for APIs. For example, I mentioned rate limiting. That's what a reverse proxy is supposed to be able to do, because you want to prevent like denial of service attacks, distributed, DDoS. But with APIs, you just don't want to do only that, because if you limit the rate, you will limit everybody at the same rate. And with APIs, you might have specific offers to say, hey, you pay this much money, so you are able to use this limit, and you pay this much more money, so you are able to use a much higher limit. While it's possible to code this into a reverse proxy, you have to understand that reverse proxy were designed at a time where like on-the-fly configuration change were not an issue. You just put a static web page and saying, hey, we are down for a few hours, and that was okay. Nowadays, it's not possible anymore. Every site, every app should be up all the time. Like this, like static web page, we old IT people, we understand about it, but regular people, they see Google, they see Amazon, they see Facebook. Those websites are never down, and other sites, for this reason, cannot be down, even if we are not competing on the same scale. So we need to be able to change the configuration on the fly so that we can update the business logic on the fly without any downtime. And in my opinion, that's what makes the difference between an API gateway and a reverse proxy, and the fact that it's focused on API capabilities. There are a couple of API gateways that you can install on-premise. There are lots of cloud ones as well. I work on the Apache API 6 project, as you can see from my t-shirt. There are others. In my demo, I will use Apache API 6. I assume others can do the same. Just 2 words about Apache API 6. It's an Apache project, as its name implies, and it has become a top-level project in 2020. So you can visit api6.apache.org. It's built on the Nginx reverse proxy, which is a very solid reverse proxy. Then on top, you have OpenResty. As I mentioned, the problem of like regular reverse proxies is you need to switch them down to change the configuration. So OpenResty is a Lua layer that allows you to script the change of configuration of Nginx on the fly. Then you have like the API 6 core layer, and then you've got a couple of plugins that are available out of the box. So you can take from the out of the box plugins catalog, or you can create your own. Anyway, now that we know about it, we can come back to how to do it. So as I mentioned, everything can be solved with an API gateway. I will have a demo. Let's do it. So as I mentioned, I will be using Apache API 6. Here I've created the Docker Compose file because it makes my life so much easier. I have the Apache API 6 image. API 6 relies on etcd, which is a key value distributed data store to store its configuration. So I have it as well. Then I have dashboard, so you can like see and change the configuration visually. I have Prometheus because I want to scrap the metrics. I want Grafana because I want to monitor the metrics. And then I have the old and the new API. Of course, normally I should first have the old API and then add the new API. But for like the reason because I'm using Docker Compose, I have everything in one go. So let's start it. Compose up. I have downloaded everything beforehand, so it should start very, very quickly. I have just like a migration of Grafana, and then because the new and the old API are in on the JVM, it might take a bit of time, but normally it should be set very, very fast. So the new API and the old API are pretty similar, as you can see. I have exposed both directly, so you don't need to go through the API gateway just to check how they work. Normally, you should hide them. They shouldn't be available outside the API gateway. And it should be okay. Completed initialization, so we can perhaps try it. Curl localhost 8081/hello. Let's check. Yes, it works. That's my old API, and the new version is obviously much, much better. So the idea is how do we move from one API to the other? As I mentioned, the API gateway should help you. So we can try to call it, and we got a 404. The reason for that is that at the beginning, the API gateway is fresh. It has not been configured. Can configure Apache API 6 through an API call. So we can create our routes directly through an API call. I prepared everything. So here you see a script. I don't assume you have curl installed on your system. So if you don't have curl, here I'm using a Docker curl image, and I make sure that we are using the same network as Docker Compose. So we can call this route, which is the route endpoint, to create a new route. Because it's a sensitive operation, you don't want everybody to be able to change your API gateway configuration. Here, you need to pass an API key. I'm using the default one because I didn't change it. Of course, in production, you need to change it to something more secure. And the payload is the following. So you can put a name, which is optional. And if the route, so this route will be invoked if it matches this method or and any of those like path. So if I send a GET request with hello or hello whatever, then it will match this route, and the gateway will forward the call to this upstream, which at the moment is the old API. And because I want everything to be monitored, I had a dedicated plugin. So if I run it, and if I call now same routes, now Apache API 6 knows about the route and forward it to the regular old API. Good. Now we are back at square one. We made everything working again. it's time to do something more interesting. Now we want to version the API, to start versioning, because at the beginning, as I mentioned, we had no time to think about it. It was unversion. We want to start versioning. There are multiple ways to version an API. You can do it path-based. That's what I will be using in the demo because it's the most visual one. You can use it query-based, like having an additional query parameter, or you can do it header-based. Everything is supported by Apache API 6, but as I mentioned, it's more visual to have the path. So I want to create a version route. I could do like previously, create a route in one go, but I can notice that there is this upstream abstraction that will be I will be reusing over and over again. And so I want to create a dedicated upstream for that. And that's good because Apache API 6 allows me creating it. So I have another endpoint called upstreams, and I will create the upstream and say, okay, I will create an upstream for the old API. And then I do the same with the plugin configuration. I could create a dedicated plugin configuration, or I can create a global rule. So with a dedicated configuration, I need to reference it every time. If I forget, I won't be able to benefit from it. With a global rule, it will be like on every route that I create by default. So here, that's what I want to do. I want to create a monitoring plugin. No, so in this case, Prometheus. So I want to create a global rule. So now I create the global rule. And the final step is to create the version route. So here, I create a new route with ID 2, and I can reference the upstream ID that I created previously. And also I will reference a plugin ID. The plugin ID is the following, and it's a dedicated plugin config. And the reason for this is I will send v1/hello to the API gateway. If I don't do anything, the API gateway will forward v1/hello to the upstream. And v1/hello, the upstream doesn't know about it. The upstream only knows about hello. So I need to remove the v1 prefix. And for this, I have a plugin called proxy rewrite. It's a simple regex query. I will say, hey, when on this route, I receive v1/something, just remove v1 and just use something. So we can apply it. So now if we curl with v1, we've got the same results. Now we have two routes. And it's time for me to show you the Apache API 6 dashboard. I've told you that you can manage the configuration of Apache API 6 with APIs. There is also a UI for that. So we can have the dashboard. I can check the routes. Of course, here I'm using, again, the default admin stuff. You should change it. And we can see that we have created two routes already. The old API unversion route and the old API version route. You can change the configuration also here on the fly. You can check the JSON and you can change stuff. Here, let's say to old API changed. Submit, and here you can see it's changed automatically on the fly. Here it's just for optional data, but of course you can change it for regular data. Here you can have the upstream as well. And yes, this is the upstream that I created. Okay, let's go a bit further. If we have an unversion endpoint and a version endpoint, there is a high chance people will keep using both, or even worse, even the unversion one, because there are less characters to type. So we want to tell people, hey, please stop using the unversion endpoint. You need to use the version one. But at the moment, we don't know who our users are because we didn't think about making them register. So there is only one way to do it, is to redirect those people to the correct URLs. If they are using the unversion endpoint, we will redirect them. So for that, I will use like the first route, the unversion one, and I will patch it with a plugin which is called redirect. It does exactly what it's supposed to say. It redirects people with a 301 to the URL appended with prefixed with v1. So let's run it. And now, if we use the unversion endpoint, and I will be verbose about it, it tells me, hey, it has moved permanently, and you need to use v1/hello, which is very, very nice. Or if we are using like automated follow, then it does what it's supposed to do. And that's very important now from a user point of view, that you always monitor your API usage from the client point of view. Because either you will have like bunches of 301 and it won't work anymore, but at least you will know about it, but it's better to monitor in any case. Or it will still work if you are using automated follow, but you will have twice the number of requests, which can be a high burden of infrastructure. So even as an API consumer, you should monitor your usage. Great. Now that's good. But I told you just before, the problem is now we don't know our users. So how do we know our users? Well, there isn't much choice. Actually, I can ask you to register, but you probably won't do it because you don't want to give away your email. You don't want to get those marketing emails. You don't want to get pestered every now and then. And I'm like you, I don't want to give my email because I don't want to receive this kind of, hey, we have a new product or whatever. But as developers, we like free stuff. So we need to provide an incentive for people to register and of course, not pester them with marketing emails. So in this case, what I can do is I can tell people, hey, now we will rate limit you unless you register. And it works. So in this case, I will create my own plugin because I've so far used only out-of-the-box plugins, but none of the plugins that are available out of the box just do exactly this kind of stuff. So I've created my own plugin. It's written in Lua. I won't delve into it. It's just like I'm not a Lua developer myself. What I did is I just copy-pasted an existing plugin, the rate limiting plugin, and I said, okay, I will just add like a couple of lines to say, hey, if I'm registered, it's fine. So here I have this call limitation, call it unauthorized limits. And now if I call, so it's on the v1, if I call it multiple times, it tells me I should register. How you register is outside of the scope of this talk. Now, regarding Apache API 6 and the code I'm using, I just say, hey, if there is a dedicated user, then I'm authenticated and I will be able to bypass the limits. So how to create this user? This user in Apache API 6 semantics is called a consumer. And I'm using, so the consumer's endpoint to create a new consumer, I'm using the most simple one, which is key auth. Basically, it tells if I pass an API key with value a header, with name API key and value my key, then I will be recognized, authenticated as John Doe, and my plugin will let me pass because I'm authenticated. Let's try it. So now I can curl and pass the header API key, my key, and I will just copy paste because I'm super lazy. And now I can call it to my heart's content. Of course, it's just a demo. You have JWT token, you have OpenID Connect, you have lots and lots of ways to get authenticated. Do whatever strike your fancy is just an example. The next step is to test before deploying. And probably you are doing unit testing, you are doing integration testing, but at the end of the day, you will need to deploy to production. So you need to test in production anyway. You are not sure about it. Most people would do canary release, which is my next step. But before doing canary release, we can be smart. The first thing that we can do is just like duplicate the production load, send it to both the upstream v1 and the upstream v2, and check that the response code from the upstream v2 look exactly the same as the response code from the upstream v1. If they have the same curve, it probably means that they behave the same and we have more confidence into deploying. That's where comes a plugin called Proxy Rewrite and Proxy Mirror. That's where comes a plugin called Proxy Mirror. So basically, Proxy Mirror will actually like send the same load as the production load to another upstream. In this case, this is this new upstream. Now I need to tell you about something important. Plugins in Apache API 6, they are run in order. And obviously, a plugin with a higher order priority will run before a plugin with a lower plugin priority. Thing is, in some cases, you don't want this order. You want a very specific order. And this is my case right now. First, I want to execute the proxy rewrite to remove the v1 prefix. And then I want to mirror the load and to send it to both upstreams. By default, it's not the case. So I need to reorder the plugins a bit by setting the priority that I want. This is what I'm doing right now. So now I can like run this plugin. I will curl a couple of times just to have some data. And remember, now I have unlimited calls because I'm authenticated as John Doe. And now we can check on Grafana if the curves, they have the same like similarities. I'm using the default Grafana dashboard for Apache API 6. What I just did is I added like two widgets, like those two widgets, one for the old API, one for the new API, and I can check that they have the same curve. So of course, at the beginning, they added the same curve because it didn't exist. But here we can see that here I have the same way. Of course, they are not on the same scale, so you need to compare what is comparable. Let's do some more calls. So normally it should like follow the same trend. So it should get back here. Good. At this point, everything is good. They both look the same. The only thing is that the upstream v2, it doesn't return the response. It's discarded. So finally, we need to do some canary release. So for canary release, I need to create my upstream v2. that I didn't create before. And well, there are multiple ways to do canary release. The first way to do canary release is like, let's take a small percentage. You can do through geographical location. You can do through a dedicated header. You can do through many different ways. Here, I'm using very simple for the demo. I will redirect half the calls to the new API and half the call I will direct to the old API. And I need to remove the proxy mirror as well because I'm using patch. So I will remove the proxy mirror and I will use the traffic split. Yep. And now when I'm calling v1, actually half of the calls will be directed to v2. Great. I'm nearly at the end. The last problem that I need to address is now I have v1 and v2, and probably afterwards I will have v3. If you have worked in product, you know that the more endpoints and more versions you have, the more maintenance effort you will have. So you need to deprecate some of the older endpoints. And for that, there is no proven solution. The only thing that I found is an IETF draft that tells about the deprecation header. So you would tell in the deprecation header either a date at which time in the future your endpoint will be deprecated, or a Boolean which says is deprecated. In the demo, I'm using a Boolean, which of course you shouldn't do because you want to tell your users ahead of time. And then you have a link header that points to the new resource. And finally, after deprecation, there is like end of life. And there is an optional sunset header that tells at which point in the future you will completely undeploy this endpoint. This one is easy. It's just adding headers into your response. So I create like the route itself with every plugin, the v2 route. And now I can like deprecate the v1 route. As I mentioned, that's an additional plugin. I don't need the traffic split anymore. I don't want to redirect something to the v2 because v2 works as expected. I have the response rewrite and I will add the headers. As I mentioned, I'm using a Boolean, which you shouldn't do, and I'm using the link. And here I'm using the Nginx variable so that it's very dynamic. So if I run this, and now I can use the v1. You see, I'm not redirected anymore to a v2 version. And if I'm asking it to be verbose, it tells me, hey, deprecation equals true, and the link is this one. You shouldn't use the v1, you should use the v2, so that's what I missed. I should have directed to the v2. And normally on the v2, everything works as expected. And here, always, I will have v2 answering. Great. And the last step is the time for the v3. And I believe if you implemented all the steps that I've shown you in this demo, it should be much easier. Like, next step is actually just to enjoy. I thank you a lot for your attention. You can read my blog. You can follow me on Mastodon or on Twitter. If you are interested about the codes, everything is on GitHub. I keep it up to date regularly, so please have a look every now and then. Don't fork it. You can store it, but don't fork it because I force push every time to have the latest version only. And if I got you interested in Apache API 6, well, please have a look at our website. Thanks again for your attention and have a nice day.
Thank you very much for your contribution. We are now moving forward with question and answers.
Okay, yeah, let me continue with the Q&A. So, and let me welcome Nicolas to the stage. We also should have Bobur. Hi, Nicolas.
Hello.
Bobur,
How are you?
we are colleagues.
Welcome you back. Yeah, happy to see you back here on the stage as you've been here many times before. Okay, yeah, so I have first question for you, Bobur, that was asked during your session, which is, does fault injection offer some kind of risk to the application as the configurations of the plugin, to my understanding, are being sent to as a request to the application?
Yeah, first of all, thank you for the question. It's actually quite interesting, the question I see. For the application, actually, there is no any risk because we are just, it's for more testing purposes. You know, when you are testing end-to-end, you can assume that next responding microservice B can simulate some errors. In this case, you can test the load or some exceptions. How can Microsoft A react when Microsoft B is responding something bad? So this is only not in application level, rather it is on API gateway level. So I don't think there is any risk on application, but if this is not enough, maybe I have my colleague also, Nicola, here. He can add his thoughts. What do you think, Nicola? No?
Nothing. I let you work. Come on. Now you have a nice house. I mean, you need to work to get to pay for this. Yeah, exactly. Yeah.
So is that the answer your questions, or follow me in the chat, like I can briefly describe. I think from the risk point of view, I don't see any risk for the backend application you have.
Okay, thank you. Yeah, though we have a few more minutes to maybe follow up on that. So yeah, let me check. So yeah, people reminding you have a few more minutes that you can ask your questions for now. But maybe everything was very clear for people from your session, Nicolas. So I'm going to grab a very, very easy torch from my CEO and ask you, like you were talking about evolving APIs, but what about in general, like with all the the AI stuff that's happening, with all the new tools and approaches? What are your thoughts? What, especially in API, what do you expect in the...
Bobur again needs to work because he has a talk on that, so he worked on the subject.
Yeah, okay, you are redirecting to me. Actually, it's nice question, Nick. I was working in two directions for how you can leverage your APIs intelligently with ChatGPT. I have two talks. Maybe next time I can propose, or I can give you when links to when my content is ready. One direction is I am now discovering is how you can use APIs together with API management for your new ChatGPT custom plugin to manage multiple backend services, exposed APIs that API management can forward intelligently to the responsible backend service. This is one direction. Second direction is how you can use APIs together with OpenAI API when it generates some AI response, and how we can cache this response, because it's about cost, right? And about also how we can secure these calls to ChatGPT or OpenAI API. This is also a topic of maybe interest for the upcoming AI maybe forum. Let me know if you're interested. I can also send out the titles and abstract. You can check it out.
Yeah, I remember I saw your submission. So that was a teaser for the talk that you will be giving on our upcoming event. So definitely, that was a very, very native on our future AI events. But Nikos, so maybe you have just some thoughts to add, and we can wrap up this conversation.
Well, so first, I'm old, so it might tint my perspective. I better say I'm experienced. I try to play with ChatGPT myself to try to help me do my stuff. I'm not convinced yet. I had a very small Kotlin snippet that I wanted to rewrite so that the algorithm was already there. It was like 3 lines of code with if else and a nested if else. And I wanted to write it using the Kotlin let syntax. And well, it took me like 2 tries. The first try didn't even compile. The second try like missed a branch, and only on the first try, like, okay, I could understand how it would do it, but I had to do it by myself. Likewise, the support in our company tries to use ChatGPT. Basically, there are 2 cases. Either you have no clue about the subject and you need to check whether it's the correct answer or not, or you are an expert on the subject and it's actually much faster to write the answer yourself. The only benefit that the support told is that the answer is, let's say, has more details. So a support engineer would answer into sentences and it's up to you to figure the rest, while ChatGPT would be more detailed, or AI in general. So that could be a benefit, but it's not the forest fire that everybody think it is. I think it's more like, before we used like Alta Vista to search for stuff, and when people started to discover Google, they thought, wow, it's going to solve all our problems. No, actually, you need to know how to query Google, and that's the exact same stuff that we are seeing right now. It's another tool. It's a bit of improvement, but it requires even more skills than before. So it's an improvement. It's not a revolution. It's just an evolution. And again, it's like, it's not because you have Stack Overflow that everybody can be a developer, because I've seen people and developers using Stack Overflow in a very, very bad way. And like developers, they can use Stack Overflow good way, Stack Overflow bad way. They can use ChatGPT bad way as well. So for like regular developers, it's going to be like a nice productivity improvement, but perhaps, we can discuss whether it will be huge or marginal. But for like other people, no, nothing will change. That's my opinion.
That's definitely a good perspective that people need to also use when looking at things. Thank you for sharing your own experience on the subject. I'm sorry. To the next moderator, I'm just gonna take one last question that we have just from the chat here. So besides building a rate limited, what other reasons to use API gateway when having an application LB and WF?
I can answer this one. So basically, beside load balancer and like WAF, I would probably use the name reverse proxy, which people are more familiar about. So reverse proxy has all the features that allow you to have a single entry point. So instead of every component behind it having rate limiting and authentication and whatever, you have this reverse proxy that does everything. Biggest difference is what an API gateway benefits compared to reverse proxy. The problem is this reverse proxy, most of them were designed at a time where API were not a thing, where you could change the configuration and restart it, and that would be not a problem. Nowadays, you don't want to have any shutdown in your service. You cannot have downtime. So basically, you need a way to change the configuration like quickly and without any downtime. That's the problem, because once you start having an API, the rate limiting is not everybody is treated the same way. Every client has, I don't know, like 100 requests per second, because such a client, they paid for, I don't know, to have a high limit, and such another client paid to have an even or even unlimited calls. So you have business logic. Now you have business logic in your reverse proxy. And so the business logic changing very, very fast. And so you cannot like restart your reverse proxy and have downtime every, I don't know, half a day or perhaps even every hour. So the API gateway, my opinion, and I know that's my own personal opinion because I've read other perspectives on the subject, is no downtime and business logic. And that's the reason to use an API gateway. So if you are using APIs, if you are providing APIs to clients, you need to have an API gateway.
Bobur, do you have anything to add to this?
No, I think how the Nicola explained it, I think there are a lot of additional features on the top of proxy server or reverse proxy that API gateway offers. And not only rate limiting we're talking about, right? It depends, like there are some API gateway providers, they have specific features with the help of plugins and extensions, and while others have only these features for the enterprise. I think we need to compare like what are the features that offers this chosen API gateway on the top of reverse proxy. This is a main important I think aspect of using either proxy server or API gateway.
Right. Thank you both so much for sharing your sessions today and for joining this brief Q&A session. I'm looking forward to seeing you on the future events and, of course, to your GPT code talks, Bobur. Thank you, and we'll be segueing in the next block right away.
Thanks a lot.
See you. Paka.
Bye-bye.
All right, so I want to welcome our next moderator, Hugo, back here to the stage.
Hey, hello.
Yeah,
how are you?
See you here today again. Doing great. The stage is yours.
Thank you. Okay. Welcome to the next block, everybody. We are going to jump right away to our next sessions. This is a very interesting forum. No? API, as everybody knows, is basically the contract for all the interactions that we have with most of the software right now. So it's really important to dive in these topics. And well, let me introduce our next speaker, Benjamin. Welcome to the stage.
Hi, everyone. Thank you for the introduction, Hugo. I'm excited to be here to speak about APIs, but from a different perspective.
Yeah. API as a product. That's nice. Let's start. Yeah, the stage is yours. Can you? I don't know. You're going to share your screen so I can add to the stage.
Yep. I'm going to share my screen.
Okay. Meanwhile, as usual, just a reminder for all our attendees, don't forget to start sending questions. It's great to have all your questions ready for our Q&A session. So it's up to you to have it ready on time. Okay, Benjamin, you can start.
Thank you. Let's go then. Thanks everyone for joining me for my talk. I hope you enjoyed the previous talks. That has been amazing. And I'm sure that the conference is going to be a blast. Welcome to my talk. I'm sorry, developer. Your API just became a product. My name is Benjamin Granados, and I work as Technical Community Manager at Postman in the Open Technologies team led by Melaine, the API evangelist. And Open Technologies, we have different teams in working in the most important standards of the API industry, like OpenAPI, Async API, GraphQL, or JSON schema, and other teams working in open source projects like Microx. In my case, I'm working as a community manager in JSON schema. And for all of those that don't know what JSON schema is a standard for validating and documenting JSON documents that is being used massively by OpenAPI and Async API, but it has many other use cases. I have 20 years of experience divided in engineering managing API programs, and now my focus is developer relations. APIs has been at the core of my job for my whole career and are still my passion, and this is why I'm here today with all of you. This is not going to be just another talk about API as a product. So we are not going to speak about the business, the strategy, or API product management best practices, because there are many great talks out there and dedicated tracks in conferences. So this is not going to be the core of my talk. Instead, I'm going to talk about how developers feel about API as a product. Why this talk? Because it's based in my own experience. I have been working in different companies from different sizes with different roles, sometimes leading the strategy, sometimes outside the strategy. And I found totally different levels of maturity, sometimes gaps in the strategy. But most important, I found teams frustrated with those approaches, and I found my own expectations not matching the reality. Right? I was sure that I was not the only one feeling that way with the API as a product strategy, and I decided to put all my thoughts together in this talk. And I'm sure that it will be valuable not only for developer and technical teams, but also for product managers, program managers, and API strategists that are working in implementing API as a product strategies. Before starting, I just wanted to check if some of you know about this amazing TV show called The Bear. And I just wanted to speak for a minute about this one, because apart of being an amazing TV show, it reminds me a lot about some of the conflicts that we will be speaking today. Very quickly, the show is about one talented chef, kind of Michelin star level, that has to return to his hometown to manage the family restaurant that is a fast food restaurant. As you can imagine, there will be a lot of conflicts to transform that place and have the technical team applying fine cuisine techniques, right? There are a lot of discussions, but in the end, a world transformation, both in the place and also in every individual member of the team. I was planning to play a video, but there was too many swear words in that. I don't want to feel anyone uncomfortable with the language, so I decided just to put a QR code here. And if you are curious about that TV show or some of the conflicts, please check it out. This is our agenda for today. I don't want to take anything for granted. So we are going to spend the first part of the talk reviewing some of the core aspects of API as a product, because sometimes the teams are frustrated because they don't have the whole context about what is going on. So we are going to spend the first part of the talk reviewing very basic definitions and some generic information on benefits of the paradigm. The second part of the talk, we will review the role of API product managers, the tactics, their objectives, and we will compare all of that, what are the expectations of the technical teams, and we will find some surprises. And if you, for the last part, you are still with me, this is the best part of the presentation, when I'm going to provide 3 different recipes to help product and technical teams to deal with some of the conflicts they will find while working together in API as a product strategies. First definition, there are many different ways to define what is a product, but I like this one because it's so simple. A product is a solution that solves a problem that exists for many people. Just that. Second definition, I know that all of us here, we know what APIs are. But I wanted to include this definition from Wikipedia because it has been the same more or less for the last 20 years with small variations. APIs are a way for 2 or more programs to communicate each other. That's it. Okay, that's true. In the more basic approach or concept of APIs, of course, that's true. But in the last 20 years, there has been a lot of different improvements, revolutions that are not being included in that definition in Wikipedia. And I'm sure that many people out there are still with this basic mindset about APIs just a single of communications with two programs. One of the revolutions that happened is a shift between considering APIs as integration solutions to consider APIs as products, to put the focus in the customer instead of the system. We are now transitioning from doing huge, ugly, complex, generic, smelly APIs to start building APIs carefully designed that solve specific customers' needs and use cases by applying outside-in thinking. We are transitioning from thinking in APIs as integration and automation enablers, just to save cost, to thinking APIs as new business model enablers to increase the revenue on the companies. And many teams or companies are right now in the middle of this shift. By the way, I wanted to provide credit to this slide to Emily Cannon and his talk, What Does an API Product Manager Do? Because it's basically the same slide, but it was so great, so I'm using that one. Thank you, Emily, for this cool content. Last definition, API as a product. So we reviewed what are products, what are APIs, both together, API as a product. An API product has a value proposition and solve customer problems, because API products is not about user experience or product aesthetics. It's about delivering value that solve a customer problem, because an API without clear value proposition that solve customer problems is unlikely to be successful. And let's review what are the benefits for companies while adopting API as a product. First benefit, improve user experience and faster adoption, because through applying product management practices, the user experience is much better, and that accelerates the adoption of the products. Is simple. The second benefit, new revenue streams and business models, because building APIs with a strong value proposition that they are much better adopted and embedded in other apps and products, and that enable new business models for the companies. Another benefit is growth through ecosystems and platforms, because building API products, those APIs are not only understood by developers, they are also understood by business representatives. And those representatives are advocating for get our API embedded in new platforms and ecosystem, which led to product-led growth. And this is key for the success of a business and API products in this case. And finally, the business favorite, reduce risk, because if we create better APIs, the whole process is more predictable, and that way we are reducing the risk and protecting the business. And now let's look at how companies are adopting API as a product. Of course, strategy and technology is important for running an API as a product strategy in a company, but the most important aspect is the cultural and organizational change required to what means the people that is actually working in the strategy. And having that in mind, we can see two different groups. We can see the companies that only know this way of working of API as a product because they have been founded in this paradigm. That those can be startups, scale-ups, API first or product companies. And of course, they will have challenges to implement the strategy, but those challenges will be totally different to the ones in the second group, in the right-hand side, the big boats. Companies that have been doing APIs for long and using different or more traditional development paradigms. In these cases, they will find much more challenges on the way because there will be conflicts, resistance to change, and other challenges. And today, we are going to focus in this second group. And the rise of API as a product has led to the creation of a new discipline called API product management. If we put 10 different development teams in a room and we ask them to define what is API product management, I'm sure that all of them will provide a different definition. So I'm going to provide one here. API product management is the practice of deciding which problems are the most important for the customer. Work with engineers and stakeholders to define the right products to solve those problems. And the practitioner of this new discipline are API product managers. API product manager is a challenging role. It is cross-functional, both tactical and strategic, and it lives in the intersection between three different elements: business, customer, and technology. Business, because the product manager needs to focus in how to maximize the business value that this new product is providing for the company. Second, customer, because the product manager represents and advocate the developer and the user needs. So I'm making sure that the new product is going to satisfy and solve the problems they found. And finally, technology, because API product managers needs to work very closely with the development teams. And of course, product managers need to have technical knowledge, because APIs are technology, and sometimes the product managers need to take some technical decisions. And if we look into the responsibilities, we can see two main responsibilities. First, define the right API that solve the customer problems, and to do it so, a product manager needs to do market research, understand the target audience, define user personas, make product discovery, identify the value proposition, do product prototyping to try and test the product with the real user, what is called user testing. And the second main responsibility, manage the development, the release, and improvement of the product, what involves backlog, roadmap, and release management, and of course, keep engaging with the customer to capture feedback and keep improving the product with the right features, right? And now that we reviewed what is API product management, what API product managers do, let's review what are the technical team expectations. And we are going to look into three different aspects. First, expectations regarding the mission of the role, expectations regarding the development lifecycle understanding of the role, and finally, expectations with the metrics approach. Let's look into the role mission. Some of the companies that are now trying to adopt API as a product, they underwent before some kind of agile transformation or stuff, right? And in agile, we all, most of the teams probably will know about one role called product owner. And probably some teams and engineers will tend to think that the product owner and the product managers will have exactly the same mindset and the same mission, but that's not true. And this will lead to break expectations and some friction sometimes. While the product owner is focused in what are we building, the product manager is focused in why we are building this. The product owner will focus in the pure development process, but the product manager is more focused in the market research and the customer needs. Product owners tend to focus too much in the business requirements, in the business value, and sometimes they are not even speaking with real customers at all. And this is a huge problem, because product managers need to serve both business and customers the same way. When a product manager, a good product manager, is serving both areas, is when that team or that product is delivering real value. And sometimes the teams are expecting a product owner just focused in satisfying the business. And when they found a customer, a product manager, like engaging actively with customers, sometimes they don't understand what is happening, because they don't know what is the benefit of that. And finally, another aspect, product owners focus too much in the development or maintainment of the product backlog, and product managers focus a lot in developing the product vision and the product roadmap. The reality, both roles tend to converge. They will, in a mature approach of product strategy or API as a product strategy, usually they will tend to converge in one, but That is not only happening. There is a lot of diversity. So this can be for sure a source of friction for teams. Second aspect of expectations broken, we are transitioning from a development lifecycle focused in requirements. So traditionally, the development lifecycle was like focused in a product product owner or project manager capturing requirements from the business, and with those requirements properly signed off, just creating a plan for the development team just to start coding and forgetting about what are the business and any kind of feedback loop or anything. Just requirements, sign off, and let's start building. But we are transitioning to a design-first approach, totally different. And in this new design-first approach, the product managers are going to have a huge role in the early stage of the development process. There are two new stages. I mean, the name, you can find different names, but basically there will be a first ideation process where the product manager will be analyzing the market, the customer needs, defining user personas, doing product discovery, and identifying the value proposition. And with all those insights, there will be a second stage, we can call it design, when all that information will be converted in an API contract using an API specification like OpenAPI, Async API, or whatever is the API style. We will create, or the product manager will create mocks to create a product prototype to do real customer testing with real users, right? And there can be kind of loops if the testing is not successful, so the process will start again with ideation. And sometimes the development teams don't know anything about what is happening in these early stages of the development process, and nobody explained it to the dev teams what are the changes between this requirements wall to this new design wall. And this is another source of expectations broken. So we need to make transparent the API product development lifecycle to show what is happening before the development. And another source of expectations broken regarding metrics, because development teams and technical teams, they are focused in building APIs right. This means metrics of quality, scalability, of efficiency, like requests per minute, latency, errors per minute, memory usage, uptime, etc. However, API product managers are focused in the market fit or the success of the product. This means acquisition, activation, and retention metrics like time to first call, API retention, top customers by API usage, usage growth, or unique API consumers. It's important for both teams to understand what is the focus of the other team. And to do it so, I think that both teams will do a better job. But this is still sometimes a source of friction and, of course, expectations not matching the reality among two different teams. Okay, we spend this time reviewing the expectations, different expectations among technical and engineering teams with the role. What can be better for us to understand what is all this role about? That putting ourselves in the shoes of an API product manager for one single day. So let's have a day in a life on API product manager. This is going to be a very extremely active, proactive product manager. But yes, I hope that this will be helpful for all of us. So what is that API product manager doing in the morning? He or she will start responding to some super requests in the support platform, because this helps them a lot to keep capturing new features and keep this strong bond with the customer, because in the end, he or she are serving the customer. They will have the team daily with the development team to review blockers and impediments and focus of the day, review some API metrics, and go to the API portal and review specs, docs, etc. And before lunch, probably that this person will be doing some API product backlog refinement. In the afternoon, for sure, some interviews with real customers, or maybe some alignment meetings with the stakeholders. And after that, this person probably will spend some time writing use cases, defining user personas, or building a real API app prototype to help other users to try the new API product. And in the evening, this person will do more market and competitive research to understand what other competitors are doing and make sure that your API product is still competitive. It will do more product discovery, because it's not only about this one, but also creating new products and diversify the company capabilities and refining the product strategy. And with this, we are closing the second block of the talk. And if you are still with me to this point, this is the cool part of the coolest part. Everything was cool, of course. This is the coolest part of the presentation. We started speaking about conflicts, and I'm going to review some of sources of conflicts and share some recipes to see how to better deal with those conflicts. First conflict scenario, regarding the different nature of product and engineering teams' mission, because dev teams wants to create high quality, high performing, scalable APIs while keeping the code clean, right? What means build APIs right. But API product managers wants to create API products that fit the customer needs, are easy to adopt, and want to do it as soon as possible. So time is critical. And also align it with the business strategy, which means build the right API. There will be always a friction between those walls, quality versus as soon as possible. And that friction can increase because APIs are technical, right? And APIs product managers sometimes will need to take some technical decisions, and the teams sometimes don't understand that situation when an API product manager is suggesting something that is pure technical, because they think technical decisions are all of us, right? But this is not true. Things like deciding the API style is connected with the customer needs, right? And who is the customer advocate? Is the API product manager. So first recipe. Imagine that we have a technical team that is amazing with GraphQL. They have an amazing technical staff. They are champions of the technology. And for them, GraphQL is like the best the best API style to approach any single API. But the team needs to build a partner API. And this partner is heavily invested in REST, right? And the product manager knows about that because the product manager has been doing a lot of research and interviews with the customer. And when they are going to discuss the requirements or the product's requirements, the product manager tell the team, hey, team, we are not going to do GraphQL, we are going to do REST. This is going to create some friction, right? Because traditionally there had been like a logic way to decide what is the best API style. I'm showing here some that I took from this article from Phil Sturgeon, different ways to decide what is the best API style. And this is pure technical, right? But now we have a scenario when we have a technical, a customer requirement. And if this is for a partner and we have clear requirements about this is the right API style for the customer for X, Y, Z reasons, we can avoid this friction among teams through creating an explicit policy. We can document the process to decide what is the right API style, and we can have, for example, this kind of diagram. And this way, this is not like a technical decision or a product manager decision. It's the policy we are applying to decide what is the best API style. And sometimes the customer requirements is first. So this is first recipe, and it's like it's a common situation, and just explicit policy like this can help a lot. And second conflict scenario, a successful API as a product strategy requires balance between these two aspects: product mindset maturity level and API management maturity level. What I mean with these two aspects, we can define product mindset maturity as a gradual process to implement a product culture in an organization, starting from 0 total absent of product strategy, to the top level product culture when the whole organization is customer oriented and the whole strategy is focused in the product roadmap with different steps in between. And if we can define API management maturity level as a way to classify APIs depending on the business value they are delivering. You can see here in the bottom part of the graph, private APIs. For example, system APIs that are like the most basic group, because those APIs are often for internal tools for employees, and when teams have to integrate it, it's by mandate. So there is no other option. You just guys has to integrate this tool for whatever is the internal process. Of course, this is helping the business, but it's delivering a small business value. It's just operational value. But if we go with partner APIs is B2B collaboration with a partner. So this enable new business model, and this has much more value than internal APIs. And in the top of this graph, of this classification, we have public APIs that are new monetization and revenue streams, and are the ones that are more connected with the business value. So we have these two aspects, product mindset maturity and API management maturity. But how we can make this actionable, how we can understand what is going on here. This is why I created the API as a product conflict matrix. I'm very proud of this. So basically, I created this matrix to help dev teams, but also product managers and strategists to understand what is going on. Basically, I'm putting product mindset maturity in its y-axis in the left, and API management maturity level in the x-axis. And when there is a correlation between both, where there is balance, this means a successful or well-directed API as a product strategy. It can be the evolution zone in the bottom left, an early stage strategy running, or it can be a mature strategy in the power zone with a mature API management maturity level with public APIs and product culture there. So that's cool. This is the ideal world. But the reality is that we can find conflict scenarios, and when there is no balance, right? And the first conflict that I wanted to share is in the top left side in orange, when we have a mature product mindset maturity combined with an early stage API management maturity. This is not per se a source of conflict, but it can lead to conflicts among team. So, and situation here is, for example, imagine that you are going to build internal APIs with too much product mindset. Imagine a company that is hiring a lot of product managers, and those product managers are applying different techniques, heterogeneous, too diverse, and that lead the team to feel frustrated, right? So there are multiple strategies, API product management strategies focused in for defining the right APIs. And in this case, the best approach is reinforce the API governance and have all the API product managers applying the same techniques and specific for APIs, like this one that is the API value proposition canvas. And the second scenario, this is the critical one, when you have a mature API management maturity combined with an early stage API management, an API compared with product mindset maturity. What this means, imagine that you are going to build public APIs with an early stage of product mindset. What this means, imagine a team that is building private APIs for very long, and the company asks them to create public APIs. The product owner is only speaking with the business. If he's only speaking with the business, there is a huge risk of building something that nobody is going to use, because you don't know your customers, and you don't know if what you are building is successful. It's just what the business asks me to do, right? You can apply product management techniques like user testing with a prototype to make sure that your product is the right one before actually starting the development. So please, let's learn from this. Doesn't matter if you started the wrong way, you can build a prototype to make sure that your strategy is working. And just to summarize, I spoke about some conflicts, but those conflicts are just symptoms or a strategy that is not working properly. I wanted to use my last slide for organizations because you can help to avoid these situations with better change management strategies. Change management is the discipline to support employees and teams to transition to new processes and tools, right? And we can use some learnings from change management to inform, involve, enable, and empower teams to actively support and champion the API strategy in a company. This is a great book, API Product Management, the QR code, if you are interested. And that was all. Thank you. I know that I was running out of time. Thank you for your patience, and I hope that you enjoyed the talk. See you in the Q&A.
Thank you, Benjamin. Thank you for the speech, and see you in the Q&A. Let me introduce our next speaker. Let me see. Hey, Samy, how are you?
Hi, I'm doing great, thank you. Can you hear me well?
Yes, all good, all good. So we are ready for your talk about AI
APIs.
and APIs, which is, of course, a very interesting topic. So can you please share your screen?
Yes, I'm gonna do that right now. Share screen. I think I just did.
Yep, there you go. There you go.
Oh,
so the stage is yours. You can start.
Thank you very much. Hello everyone. I'm Samy Melaine. I am CTO at Eden AI. I'm gonna talk about AI. So right now I'm in Lyon, in France, and I'm gonna say a little more about myself for you guys to understand my background. So I started by founding a data science and machine learning company back in 2017, where we were creating and managing AI and machine learning project for different kind of companies. We stopped at 2021 and switched to Eden AI, a solution that we've created very recently that combines a lot of AI APIs, the best APIs in the market. I'll talk about that in a few seconds. And as I mentioned, we're going to talk about AI. So I like to start by introducing AI as the holy grail of computer science, as it has been there as a fantasy from the first day of computer science. So when back in the 40s, the first concepts of artificial neurons were starting to emerge. And right after that, in the 50s, the AI research was born. And since that day, we were trying to get more and more accurate AI systems in different fields. And it was not until 2015, a few years before that, that we were getting a performance that was equal, and now it's higher than the performance of a human in different tasks, as in speech recognition, image recognition, language understanding, etc. And since that, every company in the world wanted some of that in their softwares or in their automations, etc. And that is also because 80% of the data present in any company or even in the internet is unstructured, and the classical algorithms cannot handle that. So whether it's videos, images, text, etc., we do need AI to handle that. So we're going to talk about the evolution of AI tools, the recent AI tools, or the modern ones. Very recently, but it's still a long time ago in the AI history. In 2015, there were two big libraries that were released. So I'm talking about Keras and TensorFlow. And that led to a big rush of the developers or engineering community into AI, as it made it simple for anyone with some knowledge in the AI and mathematics to start and play with neural networks and some advanced AI concepts. And that was followed very quickly by some big data platforms getting big and getting used by a lot of companies. So a lot of companies tried to join the race and integrate that AI into their systems, and they were trying to do that by integrating some data management platform like DataIQ, DataRobot, etc. So they were very hyped at the moment. They still are actually, and they were hitting their billion-dollar valuation around 2017, 2018. And that's about when we were creating Data Genius at that moment. And the problem with those two tools, was that so integrating AI with them were pretty challenging because of, I think, three main points. So that's what we observed at that moment. So a lot of companies didn't have or lacked data needed to train those APIs. Those AI models. Because back then, if you wanted an AI model to run in production on your data, then you would have to train it yourself in a big amount of the data. So we used to spend like 70% of project, a whole AI project, just on cleaning and working out the data. There was also a lack of good profiles. So we were seeing a lot of companies trying to do a lot of things with AI, but with like one-person team. So they recruit a data scientist or machine learning engineer and expect him to build all the AI systems needed for their company. And that was obviously not a good idea. And the third point was that all of that required expensive amount of expensive infrastructure, like a lot of servers for doing the training and the running part. And that led to a big number of AI projects failing. So if you read a lot of reports, you will find that number. Sometimes you will find higher, but it's approximately 85% of the different AI projects that were started that just didn't go prod because of these 3 points. So very recently, we are starting to see another type of tools that is taking up the market, that is AI APIs. So we have a lot of providers that existed from since a few years already, but they are hitting the billion-dollar valuation in the last couple of years. And among that, we have some providers around image recognition, translation, text analysis, etc. And these providers create trained models, so you don't need to do the training yourself. And they make them available through simple and very easily integratable APIs. So it won't take you a huge amount of time to use them, and you don't need to learn data science or machine learning and to go through math in order to do so. So as I like to see it, before the release of the open source packages we know now that let us train neural networks, AI was especially a field for researchers in different universities and labs. And since the release of these packages, AI was starting to get democratized to anyone who wants to do like data science or machine learning and engineering. So a lot of companies were recruiting their engineers, and those engineers were starting to do AI and join the race with the labs. Sorry. And since 2020, 2021, something like that, AI is getting more and more democratized for any stack developers. So as I was saying, you don't need to learn or follow a master degree in machine learning or data science to use it. And I think it's the most exciting period for AI because since it's democratized, the incredible projects are being built, and we're going to see it very frequently, I think, everywhere. So yeah, I mentioned 3 or 4 AI providers, but there are tens of them and maybe even hundreds, but maybe hundreds actually. They are each one getting specialized in some kind of technology or some kind of data. So you have some providers specialized in vision or image processing, speech recognition, translation, text, etc. And they are also very different as they are specialized in different domains. So you might find some of them very performant on medical data. Some others are better trained for legal data. Others for maybe log analysis, etc. So you might find very different performances when trying out these different APIs. A lot of them have pretty different costs, and they calculate it pretty differently. And if that's something that you are interested with, if you want to use, for example, only RGPD providers, then you will have to take a look at that, because you might have some providers in the US, others in Asia, others in Europe, etc. So that's another point of difference between these providers. So this makes it a little complicated to choose the right provider, but it's still a good thing that we have a lot of offer in the market. So that's still interesting. And with all of that, we're starting to see a lot of interesting ideas being integrated into smart applications. And we also have some of our clients that are also upgrading their old applications to integrate AI APIs. And I'm going to tell you about some of the examples I'm seeing right now. So first of all, and I think that's because everyone has PDFs somehow in their applications on their company. A lot of automated processing around PDFs is being used in multiple applications. And that might include like invoices, ID documents, or any type of other form document. And I think in the near future, any of your application will be expected to understand PDFs. So that's something that I think anyone will have to include. So whenever someone uploads in PDF, you are expected to be able to automatically process that. You have a lot of different very performant APIs around that. Another big subject that is being included in different types of applications is explicit content filtering. So it could be around text data, so hate speech, insults, etc. All of that should be detectable pretty easily with AI now. It also be around images. Any image with explicit content can be detected and filtered, videos or speech even. So that's something very common that AI enables pretty easily. A third application or third type of API that we'll see used very frequently is speech analysis APIs. So I think that now anyone with the speech or audio recording can finally process his or her audios pretty easily. We have a user in New Zealand who's who's processing his audio recordings from his clients automatically, as he's usually not in the office. So whenever he receives calls, users leave audio recordings, and sometimes he misses a lot of important calls. So what he does now is that he translates those audios or transcribe them into text and summarize them if they are too long, and send them as text messages to his phone from his work phone to his portable phone, and in that way he misses no calls, and he does that for all his employees. So it's working pretty well for him. And yeah, so that's something you can easily integrate with the APIs. And all of that might be kind of combined into any type of assistant that you want to integrate into your app. One of our clients that I've discussed with recently has a very interesting application with a very strong assistant where you can upload you can write text. First of all, he will understand your intent, whether you are happy or not, if it's urgent or not, etc. And he will also allow you to upload screenshots from his app to automatically detect which part of the app you are having trouble with. And you can also upload PDF files. So if it's an invoice, you understand that problem with payment, etc. And that helps his collaborators or his partners that are handling the assistance part very much, as they will find everything written in the kind of form that is extracted from the data that is uploaded by the user. So it helps him go very fast, very rapidly. And finally, we are also implementing a kind of copilot in the Eden AI platform. So I'll show you that in quick demo. And the idea is that we want to help any type of any user include any type of AI into their project very quickly. So let's try and see how that works. Yes, perfect. Yeah, you can see the screen, so that's perfect. So yeah, this is the Eden interface where we aggregate a lot of different APIs on the market. We don't develop them ourselves. We're only here to bring them together into an easy to use interface. And yeah, let's see. Might say, yeah, let's take the audio recording part or audio recording use case. So I say I want to build a let's say a tool to automatically transcribe voice messages and summarize them if they are too long, and send them by text message. So that's gonna run into our AI app, and it will propose you multiple or different AI APIs that might answer your issue. So yeah, first thing that you're gonna need is speech-to-text API. Here we propose OpenAI, for example, that you can use for that. Then you might need some generative AI for the summarization part. We'll also generate a code snippet using AI also. That's gonna give you an idea of how you can use these two APIs. So we have speech and the text generation API. And you can just copy your AI key here and try it yourself. So you can see here, if you go to the speech to text API, that you have a lot of AI providers that are gonna have different performances. So I usually encourage people to try out different APIs and see how they work. So yeah, their performance differ regarding the language and the background noise, etc. And if you want to, let's see something else. Yeah, let's try out the assistant example and see what it proposes. So we have approximately 40 or 50 APIs, different APIs that you can use. And in this case, I think we're gonna need something else. Yeah, so we might need the chat API. We might need the topic extraction API to understand the topic. If you want to reply in speech, we might need the speech API, etc. So same thing here. You're gonna get the code that you might use for this. And if you want any other API, you can check the list in here. We can try very rapidly the sentiment analysis one, as it's one of the most used APIs by our clients. So you can just copy paste the code snippet in here. I'm gonna get my API key from here. So I'm running it in a Google Colab. And it should. Yes, perfect. Okay, so I introduced my key. I'm gonna put it right here. Let's do it like this. Here I can call, for example, Google or Amazon. Let's start by Amazon. I can put a let's say something like your API implementation takes 100 years to understand. This is not very positive, as your API documentation should be easily understandable. Let's see what Amazon says. Oh, I don't think they have. Let me see like this. Okay, so Amazon thinks it's neutral, while I think it's pretty negative. So let's try Google and see what Google thinks this is. Yeah, so Google does think it's negative. So as you see, depending on what text you have, you might have very different results. So yeah, you should still have maybe some tens of, ideally hundreds of examples that you want to benchmark your provider in. Try and find the one that better respond to your data. And yeah, as you just saw, it took me maybe 30 seconds to copy paste the code and get the sentiment analysis going. And that's the same for about any other AI API you want. So yeah, I think that's gonna be all for me, because I see that the time is going by and I don't want to take more of your time. So thank you very much. And I will be back for the Q&A session.
Thank you, Samy. Thank you.
So I think, yeah.
Yeah, very nice presentation. We will see you back in the Q&A session.
Bye-bye.
Thank you. Bye-bye. All right, so let's go with our next talk, and that's improving the performance of your microservices with Andres. I will add his recorded session here to the stage. Okay, thank you.
Welcome to this talk about improving the performance of your microservices. Most of us use microservices for solve different kind of problem, and everything looks fine at the beginning, but during this time the problem will appear. The idea of this talk is show you different alternatives to solve these kind of problems. But first, let me introduce me. My name is Andres Sacco. I work as developer since 2007. Most of my time I work using different languages connected with the JVM, like Kotlin, Scala, and PHP. I participate as technical reviewer on some editorials. I publish some books and courses. Some of them appear at the bottom of the presentation. And I participate as a speaker on different conferences. On the left, you have my contact information. So if you have any doubts, any question after my presentation, just contact me, send me an email or write on LinkedIn, and I will try to help you as soon as possible. Let's go to the context of our problem. So you have a platform which have a lot of microservices and have different kind of problems related with the performance. Some of them are, you have too many requests at the same time to obtain the same information. You have biggest response. Perhaps you have, I don't know, 20 attributes in a response or an array of a lot of elements, and perhaps you only use one of them and you discard the other ones. And in another cases, of course, you will use all of them. You have different kind of problem communication on different microservices. Perhaps you have random problems. And lastly, you have a problem of concurrency. So too many requests to obtain the same information, at least at the same time. So I want to obtain the same information from the availability of some products or a flight, perhaps, at the same time. All of these problems affect in different ways the performance. So let's go to check what is the impact of these problems. So here are the same problems that I mentioned and different columns. And let's see how affect each of them. So the first one is you have too many requests, and how affect everything. Because if you have too many requests to obtain the same information, perhaps you increase the latency, because I need to obtain the same information and I spend too many time to do this in exchange of information with another microservices to obtain the same information. Affect the availability, because if something happened with that microservices that give me a lot of information, my application could suffer the problems. Increase the cost, because perhaps you need to scale up your microservices to respond all the problems related with a high concurrency of the number of requests. And of course, the resources, because increase the use of CPU and increase the use of memory on the microservices that need to respond all the requests that he received. The size of the response, what is the problem with this? Okay, affect the latency, because you spend more time to transfer the information from one place to another way. It's not the same if you download a file that only, have a size of 1 megabyte and another one that have a size of 1 gigabyte. This is an example. You spend more time to download the information. Not affect the availability directly, because it's only I can continue working without any problem if the size of the endpoint and the size of the response is too big. Affect the cost, because the transfer of information, depending on your cloud provider, you penalize if you transfer a lot of information from one data center to another data center. So these kind of things you need to consider. And of course, affect the resources, like the memory, because if you have a big piece of information in your microservices to do some operations, you need to reserve some part of the memory. Communication problems, well, not affect the latency, but affect directly the availability, because if I try to obtain something and return me an error, okay, I can't give to a response to the user. It's like I don't have any product with a description PC or notebook. And yes, you are a e-commerce that only sell notebooks. Why not you don't have notebooks? It's so strange. Affect the cost, because perhaps in a flow of 10 microservices, everything looks fine at the beginning, but at the end, the last microservices which give me some extra information produce an error. And with that error, I only return an exception to the client. So I spend a lot of money transfer information from one microservices to another, just to say, okay, there is an error. I will not show anything in the UI. So you waste a lot of resources. The concurrency, well, the concurrency affects everything because you have more latency because too many requests try to obtain the same information at the same time. So take more time to give me a response. Affect the availability because again, if the concurrency is connected with dynamic information, if something happened with that microservices, with that endpoint, you lose everything. The cost increase because you do many times the same information or you transfer the same information between the different microservices a lot of times, and it's not a good idea. And of course, increase the use of resources. So why these approaches fail? And there are different reasons, not just one. It's not, oh, the main problem is this. No. First one is you don't document the decision. Perhaps you take a decision like, okay, I want to use this technology, or I want to use this one. And okay, write a document, explain your decision. No, I don't have time. And during this process and the evolution of your platform, at some point you say, oh, this approach is not the best. Why we choose this one? And you have any kind of information. Perhaps one person on the entire company know the idea of this technology or this solution. So this is a bad practice. You don't consider the trade-off of each alternative. So the best idea is like create a document and you need to analyze like different alternatives. A way to do it is a document which is called architecture design record. And the idea is you put the different alternatives, the pros and the cons, and you have to explain your decision and who are the people that approve that decision. So it's a way like consider the trade-off and at the same time document the process. You tackle one part of the problem, not the entire. It's like, oh, I detect a problem on these two microservices and I will solve it and I will do nothing more. And perhaps, okay, you can analyze the entire platform because the entire platform could have the same problem. And these kind of things, and you need to consider when you do an analysis of the problems. And thinking in one language is like, oh, I have the solution with this problem. We can use this library. And you need to put the focus on the problem. Which is the problem and which is the solution. And after that, you can say, okay, I need to find an implementation that give me these kind of features. This is the best approach. So, dealing with the static information, like too many requests at the same time to obtain the same information. Well, perhaps not at the same time, but you have microservices which contain a lot of static information, like, I don't know, the cities, the currencies, the airports on the country. So that information not change frequently. You don't appear each day a new airport, a new city, or a new currency. It's so strange. So perhaps change once in a week, in a quarter, or in a year. So it's not frequent that happen. Need to have high availability, as I mentioned. If that microservices that provide information to multiple microservices is down or is working bad, could affect the entire platform. So it's so important that these microservices need to be healthy for us. And well, as I mentioned, could be an API that have cities and countries. And perhaps you need to consider a mechanism to save the information temporarily. And that mechanism is the cache. So is the cache the possible solution? Well, reduce the traffic between the different microservices because save the information in one place. Could be different places like the cache proxy, in memory, or external, and depending on each mechanism is the place where you save the information, like in the memory of the microservices, in external place like a database, or in front of the microservices. But you need to consider the size, the number, and the time that you will save this information, because it's not the same, say, I don't know, the information about a city that perhaps is 1 KB, and perhaps if I need to save another part of information which have a size of 2 megabytes, it's not a good idea to save too many rows of that information. Try to combine different types of cache. Always not try to think like, okay, this problem, this type of cache solve all my problems. It's not the idea. And find a way to invalidate the cache. If something happens, if you have some bad information on your database or in the microservices, you need to find a way, like say, okay, discard all the information because have a lot of problems. And think the solution in an agnostic way, not just think in one technology. So what is the idea of the cache in memory? So it's the simplest way to implement for different reasons. First one, because you only use a piece of memory on each instance of your microservices to save the information. So the provider of the information is not necessary to do any modification. So if you consume an external client, an external provider of the information, which is, I don't know, is outside of your company or outside of your team, you don't need to say, okay, please implement a mechanism of caching. Like I can do it. Not all the microservices have the same information, and here is one of the biggest problems, because imagine that you have two instances of the same microservices. One of them do a search and obtain and save the information from Buenos Aires, of the city of Buenos Aires. And the second one receive another request and save the information from Miami. So you have the first instance, which have the information of Buenos Aires, but not have the information of Miami, and the second one, which have the information of Miami, but not Buenos Aires. So each instance have different kind of information. So the problem with this is when you scale up or down, you miss information. Imagine that you have only 2 instances of your microservices, and for some reason you scale to 10 instances. Okay, the new 8 instance not have any kind of information and need to receive new requests. So you have these kind of problems. Some implementation of this, which are connected with the JVM, are Wawa and Caffeine. Are 2 examples of implementation. But try to think the problem in an agnostic way. I only mentioned like as an example. Use this mechanism with the static information, which not change frequently. Again, the idea of this is try to save this kind of information for a long period of time. I imagine that you need to save the information of a cities. Perhaps you can save for, I don't know, 3 hours, 4 hours, 6 hours. But you need to consider the number of elements. It's not like 6 hours, all the cities that these microservices receive. No, I don't know. You can save 10 cities or, I don't know, 100 cities perhaps. Always think in the size and the number of elements that you want to save in the memory. And yeah, take in consideration the size again. So next mechanism is the opposite, this cache proxy. And the idea is put a mechanism of cache in front of your microservices. So the modification need to do the provider of the information, not the consumer. So as I mentioned, the mechanisms appear in front of the microservices, which is a benefit. All the microservices have the same information. Remember the example that I mentioned, which you have 2 different microservices, and both microservices could do a request to another URL to obtain the information, and behind the scenes this URL have a cache And if the information is not in the mechanism of cache, we'll do a request to the real API, obtain information, and return the same information for both microservices. And when another microservice try to do the same request, the mechanism of cache say, okay, I have the information, I will return it. Nothing happens if you scale up or down the consumer of this API, because it's the same for me. All the requests pass from one place. This, as I mentioned, not imply that you need to modify the consumers. It's like, okay, I will do everything and you will not change nothing in your microservice. The bad thing is you need to, all the requests that you do from one microservices to the other microservices like the cache, you spend perhaps money transferring information from one place to another. So you need to consider the trade-off of this alternative. And you need to define on the configuration of this mechanism the expiration, because it's not unlimited, like forever. No, you need to say, okay, I don't know, 6 hours. I will save the information of this endpoint for 6 hours. External cache. This is a little variant of the first one, because you save the information in external services that could be a database. The requests go directly, first one to the database or the other tool, check if the information exists or not, and if not, we'll do the request, the microservices, to the real microservices, obtain the information and save in the cache. Nothing happened because, again, like the previous example, you have a central place where you save all the information. And implementations of these mechanisms could be Redis, Memcache. There are other ones, but the most popular are Redis and Memcache. Increase the cost because you need to maintain a database, and a new database in this case implies that you need to pay for that database and the transfer of information from that database. So things to consider. Well, there are multiple things. Before choosing one approach instead to another, you need to consider the different type of mechanism of cache, the duration, like the frequency of the changes, and the relevance of that information. So if that information is so relevant for me, there are a lot of number of requests from that microservices or that endpoint. And the last one is the number of elements, like the size of the element and the hit radio, like how many times another microservices try to obtain the same information. Imagine that, oh, I don't know, I have an endpoint of the cities and I have a lot of requests at the same time to obtain the same information. Oh, this is a huge hit radio of the endpoint. And I have another endpoint which provides some information and receive only a request in a week. Okay, a request in a week perhaps not apply the use of cache. And it's not relevant to say a lot of time the same information. So this is the way to connect all these things. Next topic. So is the size of the information relevant for us? Well, increase the time to send and receive data from the different microservices. Not all the information is required. Perhaps you send a lot of information, as I mentioned, and you only use 2 or 3 attributes and you discard the rest because are not relevant for you. Could be static or dynamic. It's the same for us. So the problem is the size, not if the information is dynamic or static, because if connected with the previous one, and perhaps you say, oh, I can solve the problem using a mechanism of cache. Yeah, but you only solve part of the problem. The other part, which is the size, you don't solve it with the cache. It's increase the cost depending on your cloud provider, because some cloud provider charge you in the bill the transfer information from one microservices to another one. So you need to consider these kind of things. And lastly, implies more uses of CPU and memory, okay, because you need to parse and transform a lot of information at the same time. So, which are the solution of this? Well, compress the information. And why you compress the information? Because reduce the size of the information that you travel from one place to another one. So if your cloud provider charge you for the size of the amount of information that you travel from one place to another, if you reduce the size, you reduce the charge that the cloud provider put on the bill. Of course, decrease the latency, because it's not the same transfer a big file with information like transfer a small one. But it's not a silver bullet, have some cons also. Because increase the use of memory and CPU to decompress. I did a lot of tests in real scenarios, and using a T3 medium on Amazon Web Services, the increase of the use of CPU is like 5%. So you need to consider, like, depending of the size, the use of CPU increase at least 5%. You need to define a mechanism to compress and decompress the information. There are some frameworks that do for you, but the other ones do nothing. Implies that you need to add a header on your request to say, okay, I support that you, the provider of the information, can send me everything in a compressed way. And it's possible to implement on the database. Perhaps you can save the information compressed, like in the case of Redis, or you only compress the information on the transfer. And there are multiple implementations like Cassandra and Elastic, which give you different mechanisms to compress the information on the transfer across the network. Or you can do the same, like, okay, I want to send information compressed, and you save in the database in a compressed way. The cons of this is you need to find something in a database. You have the information compressed, so it's difficult to find something. And some frameworks support naturally, like Spring Boot on Java. So you only need to add some configuration and everything, it's magic, and the framework do for you. How to improve the previous solution? Because, okay, I have compressed all my information, but the problem, again, is the same. I only use one attribute for the response of that endpoint, and I discard the other one. Well, you can create another endpoint with some attributes. So it's like I will return just a small response, or you can add parameters to omit or discard part of the response. It's like I will populate only 2 attributes or 3 attributes, depending of the parameters that I receive in the request. An alternative is use GraphQL, like you have the possibility to create a dynamic response, so return just the attribute that the consumer needs and not the entire response. This is another way to do it. And the problem with all these alternatives is who maintain all the endpoints, because the idea is that in the case of GraphQL, perhaps you only need to maintain the part of the logic that is like receive the request and response, but someone need to maintain all these things. You need to consider the trade-off of this. Dealing with the concurrency, well, it implies that too many requests at the same time try to obtain the same information, and is connected partially with the first one. Could imply that complex operation to obtain the same information, like I want to obtain if I have a stock of some product in a big e-commerce or like something like that. Imagine a big event like Black Friday or Cyber Monday, where everyone try to obtain or find the same products at the same time. And the problem with this is always imply complex operation. It's not like it's show you an image. No, you need to obtain the stock, calculate the price, and calculate how is the amount to shipping from one place to another. It's not a simple operation. Could be connected with static information, at some point, and there are a chance that not, and implies an increment of resources at the same time. So if a lot of people do the same request at the same time, implies that you need more instance and more CPU and more memory to resolve all the requests. How to tackle this problem? Well, there is not a unique way to do it. And you need to analyze the trade-off of each possible alternative. Like, the cache is not the unique solution because only solve part of the problem. Like the static information, it's okay, I can solve it, but you need to consider a different kind of mechanisms. And what happened with the duration of something that is dynamic, like the stock or the availability of a product, and what happened with the, I don't know, if a flight is available or not in a travel agency. There are many things to consider, so the cache solves a part of the problem. Limit the number of requests. Okay, I will say that I will only receive 10 requests per minute. Yeah, everything continue working fine. We decrease the use of resources, but we lose clients and we lose money. So this is not the best solution, but could be an option at some point. And the last one, which could be the final solution, is use a mechanism of semaphore. So one of the requests, imagine that you had 2 or 3 requests at the same time to obtain the same information. The first one, I will say, okay, pass and try to obtain obtain the information and execute the entire flow, and put like a barrier or something to notify the other ones. And the other microservice, the other request say, okay, there are another request which try to obtain this information. Yes, okay, I will wait. And when the other one obtain the information, I will copy the information and return the same one. So, what imply the semaphores? You need to create a mark or a barrier to protect the double execution. So you say like, okay, you pass, you wait. Implied that other requests need to wait. So imagine that you need to create a mechanism to notify when the first request obtain the entire response. Say, okay, I have the information for this request. Who of you need that information? Okay, this is the information. Return. Increase the use of resources like the memory and CPU, because the other requests need to wait at some point until that the first request obtain the information. And it's ideal for travel agency and e-commerce and for big events. So again, try to think all these mechanisms as a combination of the different alternatives. Problems with communications. Well, random failures on one of different microservices that could affect the availability of our site, imply too much transfer of the information between different microservices, and you waste all this transfer because you lose everything. But working on a part of the platform, this kind of problem affect. And the last one, you detect that these problems using chaos engineering. So you can create different kind of experiments, and you will execute and detect that the problems on your platform and how prevent that problems. How tackle these problems? First one, you have multiple approaches. Like there are some manuals and there are some other like automatic, like manual, like, okay, I will stop the microservices, or I will, I don't know, stop the entire platform. This is manual. And perhaps you can create a mechanism that give you some response in an automatic way. You need to find the problems, where are the different places that have the problems, and find a possible mitigation with this problem. And try to use existing solution like resilient pattern that cover most of the problems of communication. What imply this pattern? Well, you need to consider different aspects, like which are the patterns that you will use considering the different microservices, which strategy you will use. Okay, I will use a fallback method to return a default response in the case that something bad happened, and define a threshold, like the number of errors or the percentage of error that will activate that patterns. Sorry. And you need to define alert to notify that something bad happened and notify to someone. And combine with other mechanisms to like cache or multiple requests at the same time, like the semaphore. Best practices, and this is like the end. See the entire picture, not just one part of the problem. Analyze the trade-off of different alternatives. Not generalize, not assume that this solution works in every context, on every place, on everything. You need to consider the trade-off. Document the solution, please, because it's so relevant for us to understand why you choose one thing instead to another one. Think on the problem, put the focus on the problem, not on the libraries and the frameworks. It's so relevant for us, like, okay, not thinking in the solution, and combine different mechanisms of solution, which give you a lot of increasing on the performance. Future readings, here are some books and blogs which have a lot of information for you. Please try to find or read some of the blog which have a lot of information related with that problem on the performance. And thank you. That is the end of this talk.
All right. Okay. Very interesting talk too. Let's go ahead with our next speaker. Raymond, welcome to the stage.
Thank you. Good morning. Afternoon.
Yeah, all good. So we can hear you. Can you share your screen so I can add it to the stage?
Absolutely. Entire screen. Screen one. All right. You should be seeing my screen, I hope.
Yeah, there you go.
Cool.
Okay. I think if you're ready, we can start, Raymond.
Absolutely. Let's get started. Good morning. Well, it's from me in my time zone, everybody. Let me just quickly give a little warning. I am not feeling the best today. So if I sound like not enthused at all, trust me, I am very much enthused. I think the saying is the spirit is willing, the body is weak. But I can do this. I have full confidence. My name is Raymond Camden. I am a developer evangelist for Adobe. My primary focus is a set of APIs that we have related to documents. So kind of simple stuff like converting a Word document to a PDF, to more advanced stuff like dynamic PDF generation at scale. I'm also working with the Photoshop APIs and generally just tend to work with APIs in general. I've been in development for a very long time and have always enjoyed building integrations with APIs, taking somebody's data, mixing it up, and doing something fun with it. I will say I am blogging at Raymond Camden, so if you want to connect with me in any way whatsoever, I have email there, I have my Mastodon account, et cetera, et cetera. You could definitely reach out to me there, and please feel free to kind of follow up and ask about this presentation or anything at all. So my, let me move that out of the way. My basic thought process for today is to kind of speak about the things that you should be avoiding when you are shipping an API. And there's going to be a lot of back and forth, a lot of kind of sarcastic, hey, you should totally do this because it's going to ruin everything. And then a response to that saying, obviously, you should not. And I'm going to kind of cover it in the time frame or timeline of a developer journey. So, for example, like what I see when I begin to think about using your API, to when I'm using it, to when I need help. So it's kind of like that kind of overarching way of looking at someone who may be considering using your API. Now, in terms of who this is for, I am primarily thinking about API first companies where the API is the product. There are definitely sites out there that just randomly have an API. Letterboxd is a movie/TV social sharing network where users can go in and they could say, I watched this movie, I give it 3 out of 4 stars, whatever. They have an API, but it's not really their main thing. The team that I work on at Adobe, all we have is an API. We don't have any other product. Well, obviously Adobe has other products, but our particular team, we are just shipping an API. Now, there's definitely some gray area there. There's some instances where maybe you have a core product and you have an API and it's almost 50-50. And I have an example of that towards the end. But hopefully some of the things that I'm pointing out will still be useful in those cases. So as a warning, when I say that you should do X, Y, and Z, it's completely fair for you to say, hey, you know what? Our company is 5 people. We're a startup. We don't have time to do X, Y, and Z. I completely understand that. But I want you to bear in mind, I and other developers, we don't care, like, period. You could be a plucky startup with a heart of gold and you really mean well. But if your API is your product and you want people to use your product and you don't do the best job that you can, I'm just going to move on, maybe to an evil giant megacorp that is actually supporting the API and giving me what I need. So there's, I'm absolutely going to be presenting kind of a ideal world, best of all worlds type scenario. And I understand that that's definitely not always going to be possible. But just kind of keep in mind, developers are fickle. They can leave you in a heartbeat. There's a certain social media company that you may have heard of that is kind of suffering with kind of a revolt. And it's funny, me saying that, there's like multiple answers to that question. We'll be talking a bit about that later. All right. So with that out of the way, let's kind of talk about starting off on the wrong foot, like definitely doing things the wrong way. So one of the things you could do is not actually link to the startup process or the sign up process. I have absolutely seen this where I land on your marketing page and I'm like, hey, this sounds kind of cool. And then I have to hunt for where to actually sign up. So if you don't want users, that's a great way to do it. Our company at Adobe, we do things, we actually want users. So I will point out that like we have 2 different call to actions on our website that get you to the startup process. And we found that I think we had 1 initially, adding 2. It definitely gave us a bump to our signups. You definitely don't want to make it easy to sign up. And I will say Adobe used to actually do this where we had lots and lots of fields. My favorite field is the one where they ask me how big my company is. I've been at Adobe 2.5 years. I have no clue how big Adobe is, how many employees. I don't care. I always lie on that field. And we all know where this comes from. This comes from marketing. When they want to know, hey, of our devs who signed up, what's their size and all that. That's where that comes from. And I just, speaking for myself, I just pretty much ignore it or lie to it. The other thing I've been seeing lately, and not a lot, but I see it growing, is sites that don't allow you to use Gmail to sign up. And even if I'm absolutely doing something for my day job, I never want to use my work email address, primarily because, we work in tech. We change companies, and I don't want to have a sign up for my personal account, or if you even allow it, and a sign up for work. And then if I leave my company, I have to transition resources off there, make sure some stay. yeah, I'm seeing that more. It just bugs me. The other thing you probably don't want is automatic approval. You really want people to wait, and you don't want to give them any kind of clue. Like just say, "Hey, we'll get back to you eventually," and leave that up in the air. All right. So obviously, that's all the things that you don't want to do. So surely, link to sign up, make it really easy to do. And I definitely think it's fine to ask questions about the user, even if they're optional. Just kind of keep in mind, like if I see a form and there's like 20 fields, excuse me, even if they're optional, it's going to be a bit intimidating and may actually turn me away. You really, really want to consider automatic approval where appropriate. And this is kind of a gray area because if your API, for example, has anything to do with, let's say, social media, places where abuse happens, I can absolutely see an argument that could be made for not automatically approving someone's access to that. Um, so when I say you should always automatically approve someone to work with an API, something that creates content, something that creates public content would definitely be a case where I could understand. If you are going to do it, absolutely be clear. This is from the National Park Service API. They have a great API. I'm going to be showing both positives and negatives. I think that's true for everybody. But they actually tell you like what to expect, like within 1 hour. And I love the fact that they say, hey, if for some reason you don't get it, reach out. Uh, this is the only company that I've seen that has done a good job with this. And there's probably more out there. But so far, at least, this is the only one I've seen that has done such a great job in clearly communicating what to expect. There's also this idea of applications, and I put that in quote because different companies do this different ways, where I sign up for a developer account, but then further from that, I have to create projects or credentials within groups, etc. An example of this is Spotify, where I've already logged in to their developer portal, but then they want me to create an app that represents what I'm going to do with their APIs. Typically, this allows for segregation in terms of I'm using my API key for this client and I'm using a different key for that one. Adobe has a concept as well called projects that can get actually pretty darn complex. So this is a pretty common thing, but my same don't suggestions apply about asking too many questions and requiring things that aren't required. And again, the same opposite thing that I'd recommend still applies. So really try to make this as minimal as possible. Another thing to look at is if you need to do any kind of checking on a person's project, make sure that they're okay. I think it's absolutely warranted to let somebody start using their API, but add a temporary throttle or usage limit of some sort, such that maybe you need a human to look over what they're doing, but in the meantime, they can still absolutely begin working on their integration. Also, another big thing that I rarely see, a lot of companies want to ask you how you're using their API. And 90% of the time, and I'm definitely an edge case. I'm a blogger. I play with tech all the time. But very, very rarely do they have a option to say, yeah, I don't have a use case. I'm not going to production. I am learning your API and I need an environment to do that. I can't believe I'm doing this, but I will link to Twitter because Twitter is so far the only one that I've seen that will do this, where in their list of use cases, they recognize that I just need to explore the API. So this is potentially the only thing Twitter is doing right these days. But to be honest, I'm happy that they have that there. So let's talk about actually using the darn thing. And at this point, In our developer journey, we have, we've registered, we've set up whatever we need to, environment, whatever, and we're actually to start writing code to work with your API. So there's multiple things that you can do wrong here, and we're going to talk about all three of them, and they are poor documentation, stringent developer requirements, and then inconsistency. So let's talk about docs. Docs tend to be one of the last things people work on, and working in developer relations is something that's very much on my mind. And you can tell when someone has spent no time working on docs. So some of the things that you can do wrong is to put docs behind a login. I've seen that where you can't read the docs for an API until you register to use for an API. And the only time where I've actually gone through that process is when I had to for work. I've absolutely turned away from a product that requires that, because if I have no idea how hard it is to use your API, I'm not going to go through the process of signing up, especially when you're probably going to spam me about your product for a while. Definitely, spend 1% of your time on the docs, and don't actually bother finishing it. And look to put the absolute minimally required text. And what's an example of that? And I mentioned NPS before, the National Park Service, as an API I really like, and I pointed out something positive, and now I'm going to point out something negative, and it's kind of particular, but I know I picked up on it when I was looking at their docs. So this is one of their endpoints. It's the activities endpoint, and the very first thing I see is that I could pass an ID to it, and that could be one activity, one ID, or it could be more. So right away, my brain goes, all right, so how do I delimit those IDs? Is it a comma? Is it a plus sign? How do I separate them? Next thing I go to is there a max number of IDs that I can fetch? That's all the kind of data that should be in the docs. If we drop down to limit, where it says, the number of results and the default is 50, once again, uh, my brain goes to, okay, so what is the max? I don't have an arrow for it, but hopefully you could see my cursor. Another kind of fun one, this sort argument down here. Let's read that second sentence. The sending order is assumed for each field unless the field name is prefixed with the unary negative, which implies the sending order. Not that I can see you, but like raise your hand if you read unary negative and you understand what that means. I don't. I did look it up. It basically just means a minus sign. Write the word minus sign or use parentheses and actually show a quick example of it there. One more minor thing that I'll point out, mostly because like I tell our docs people all the time, in terms of consistency, the fact that term is not capitalized and everything else is, I would fix that. It's not something that would turn me away from an API, but it is something that I notice. And while you're in there fixing the other things I point out, go ahead and fix that as well. One more thing I'll point out, and I see this a heck of a lot. This is the endpoint, the get activities. So you see, slash activities. What is the root URL? What's actually the API URL? Now, some of you probably see it. I do not, and we'll get back to that in a second. So when I actually needed that, because this page I'm on is all the endpoints and all the parameters and all that, but it never showed the endpoint. I had to go to their getting started thing, which begins with the sign up form, and then as you scroll down, casually mentions what the endpoint is. Now I will go back. I'm going to go back 2 slides. So I'm building this slide deck, and I'm looking at the slide, obviously, and I look on top, and I was like, oh, yeah, there it is, developer.nps.gov API v1. In my defense, this is really important information that they put in small text in light gray. It's like they don't want you to see it, which obviously is a mistake. if we go to my company's APIs, let me keep going ahead. We do it kind of nice. So on the left is what you see by default. So we have the endpoint, payload, and stuff like that. I didn't notice at first, but we do actually have this caret here. And if you click on the caret, it expands and shows our two root URLs. We have different regions we support currently too. So that is one way to quickly see without going back. And so I get the idea here. The UI designer was thinking, let's focus on the important part. In an API, typically the root URL is never changing. It's just the endpoint. However, if I Google and I come in and I land on your reference docs, I may miss what that root URL is. I would say, in the interest of saving space, do something like this, perhaps. Go ahead and use light gray, but still include that root URL. I have bolded, I have made it black, changed the color, etc. So visually, I'm still seeing first the particular endpoint that I care about, and the root URL is not changing. But if I need that to do a quick test, I have easy access to it. So some more docs consideration. Keep in mind that there's a huge difference between a reference guide and an API getting started guide. Now, not everybody needs it. If your API is just the weather and it's one endpoint and you pass one thing, let's say a zip code, postal code, whatever, there's not really much a getting started would do there. It certainly wouldn't hurt. But if you have one of those APIs that are multi-step, which is common and more intensive, or binary related APIs, like for example ours with PDFs, it's more common to have a multi-step process. And definitely consider doing an example in that. And to be clear, blog posts don't count. And as a blogger, that makes me feel sad. But I'm not gonna, if I'm trying to learn how to use your product, I'm not gonna hunt your developer blog because it's gonna be random stuff. I expect the core documentation to have information about actually how to use it. And to give you a reason why this is important, this is our REST-based APIs. It's actually a 7-step process. So you do a REST call to get an access token. You do a REST code to ask for a upload asset, like I need to upload a HTML document. I then upload the document. I start a job, a convert HTML to PDF type job. And then because this runs in the background, I do another call, sometimes multiple times, to pull it to say, hey, are you done? When that says it is done, I then do a final call to download the bits. Now, that's a lot of steps. It's also a lot of really small atomic steps. To me, technically, it's not hard to do, but I absolutely point people. Unfortunately, just in my blog post, we don't have a doc for this yet, but I point people to my blog post that shows each of the 7 steps. So another thing you don't want to let them do is don't let them just HTTP, right? Because, just because it's in the web doesn't mean it should work via HTTP. You probably want a multi-step complex authentication process. Great example of this. It's kind of API related. If you do anything with Alexa devices, and hopefully you don't have one in the room, I just triggered it. When you write your serverless code to respond to Alexa requests, when you go into production, you have to make sure it's a secure request. In other words, it's only Amazon sending the request to your endpoint. And they have a 7-step process that validates it. And that's just really, really crazy. Luckily, there's libraries for all that that make it a lot easier. Another thing you can do is don't let localhost work, which is silly. But if you want to be mean, you can do that. Or don't let HTTP localhost work. So I have seen one particular API that requires you to create a temporary HTTPS certificate in your local environment. just to call their API to test. And that's not impossible for sure. In fact, they kind of walk you through doing it. But it's silly as heck when like almost every service out there lets localhost work. So again, going to the opposites, look at how you could simplify authentication. Google has a package, for their authentication. That's something I found with Google APIs a lot. It was not uncommon for me to spend 2 hours working on their API and an hour and a freaking half, pardon my language, was just getting the darn authentication to work. And literally, once I got passed off, yeah, their API was relatively simple. Adobe is actually looking at making the authentication part of our process simpler. So we'll still have a multi-step process to work with APIs, but we are going from 5 different credentials down to just 2. Certainly, whitelist localhosts. We have a embed API for PDF. So it's not really an API. It's a JavaScript library, but we call it an API. But one of the things we do is that we require you to have a key to use it, and we don't whitelist localhost. And that really bugs me. And I've asked for a long time if we could just ignore localhost. And I think it's absolutely fine to require HTTPS, but give a pass to that on localhost. A lot of web APIs do this, where you can't use a particular web API in an insecure manner unless it's on localhost. So we talk about consistency. As a developer, I love to be surprised. Surprise me all the time, please. I've seen things, for example, where one particular API endpoint will use max and another will use total. Let's just keep them guessing. And obviously, don't do that. I love a boring API. That's something I say about a lot of our Adobe Acrobat APIs is that they're pretty boring because they just do a simple job and they do it well. And I'm okay with that. Ideally, if I work with one of your endpoints and I know you have another endpoint, I know the name, I could probably hit it without reading. Of course, I'm going to read the docs, but if I can guess a lot, that is really, really nice. And keep in mind, consistency also applies to both input and output. So if you have a standard way of returning result, let's say weather forecast, and you have different results. So let's say a today endpoint or a 7-day endpoint. Ideally, the information for today should match the structure of the information for your 7-day forecast. Only difference being that in the 7 days, you would have 7 of them. So let's talk about support. So if you don't have any support requests, that's great. That means that your product is perfect, right? Or it means you've completely stopped someone from doing it. So if you're going to have email support, again, clearly discovered, little typo there. Make sure it's easy to find and be honest about timelines and actually have a human. I strongly recommend forum supports because my guess is that a lot of people asking for help are asking things that people have already asked. Now, you could build a FAQ. I recommend that as well. But if you have a forum, before I post, I'm going to ask, I'm going to search to see if my questions have already been asked. And the nice thing is that sometimes your users can help you with support. They should not be your only support, but they can help you by answering questions already. Stack Overflow is also a good thing, but keep in mind that still work. You want to look at your tags that support your product, make sure people are using them. And, if you have support staff, and you should, make that part of their job is actually going there and looking for questions to answer and help other people's. So as I'm wrapping up, I can't talk about do's and don'ts for APIs without mentioning some people who have been in the news lately for being really, really upsetting to developers. Obviously, I don't work at Twitter or Reddit. I am a small peon at Adobe. I don't run them. I can only give you my opinions in terms of things that I would do. So one interesting part about both Twitter and Reddit, APIs aren't the primary product. Probably the primary product is the user, pretty much. The user content and stuff like that. But they are heavily used at these companies, especially Reddit, with the third-party reader applications out there. Twitter with useful bots. There were a lot of spam bots, but there were bots that were doing things like posting train schedules and stuff like that were useful. It is sensible to charge, but kind of keep in mind that a good free tier leads to free evangelism. Before Twitter made its change, I enjoyed working with their APIs, and I blogged about it, I talked about it, I shared examples, and I was building stupid toy stuff, but I was still evangelizing their product for them, and I'm done with that. Like I'm not going to bother. And something to keep in mind as well, free trial is not the same as a free tier. My team at Adobe, we had a free trial, we still do, and very generous. But I think a free tier is better, and we're actually moving to a free tier in like a week, which I think is better because it means I could build something and I could keep running it. And even if it's just a toy, I don't have to worry about shutting it down. And I think for both Twitter and Reddit, is that if you start altering, the basic mechanisms of how a person can use your APIs, you're going to burn a heck of a lot of goodwill. So darn well, make sure it's worth your time before you do that. Try as much as you can to not do that. Again, that's life happens, things happen, but really, really try your best. So with that, I'm going to wrap up, and I see I forgot to type that stuff in there, but that's all right, because I believe we are going to a group Q&A now. Is that right?
Yes, that's right, Raymond. I didn't notice any of your feeling that you're feeling bad. It was a great presentation, actually. So thank you for the fight and the effort.
Thank you.
Do you have the energy to stay in the Q&A?
I'm going to stay in Q&A. If I go away, I apologize in advance.
No worries. Let me include everybody. Andres, Benjamin, and Samy. Hey, everybody.
Hi.
Okay, so now it's time for our Q&A session. I tried to, as you saw, and also when we started this blog, I tried to go as fast as I could, giving you the stage so we don't waste time. But now I think we are like in an open moment where we can talk all together. I'm very passionate about anything related to software because, of course, that's my field. And APIs, this forum is giving us a lot of good knowledge about the contracts. I tend to always relate this to a contract. No, APIs are basically the contract that us as developers have with anyone that is using our APIs. And yeah, one of the last slides that you had, Raymond, made me laugh a lot because, let's keep guessing. We want boring APIs because that makes our lives easier. No, we want to use them, not to really have to learn all the different variations based on each developer. No, so it was great, guys. So let's start with our Q&A session. We have our first question here for Benjamin. It has two parts, by the way. So it's a company with multiple product teams who each own their API endpoints. How could a single API product manager affect changes? And the second part, the second part comes after you address this part.
Okay. In my opinion, I mean, it's not an easy question because this means product manager is engaging with different development teams, and they have to co-own some part of the API. in my opinion, here, what is critical to start in the right way is having a common API catalog or repository to make sure that everyone is able to collaborate in the API contract, and this is critical. And having that in mind, I think that we can rely in some kind of processes, API governance, and automations through GitHub or whatever is the tool that you use, so the people can have organized way to increment the API, right? And I mean, in this case, if the API is there, what is critical for me, more than the API product manager itself, is the API governance approach, both human and automatically through processes. And second question.
Yeah, it's when the API product manager is not part of those teams. No, it's basically like trying to organize everything.
Yeah, I saw some. I mean, I didn't saw it. I discussed with some colleagues in other companies when they don't have a dedicated product manager. They have product managers that are involved in the early stage of the development, and they are just ad hoc being involved with very mature companies. So in my case, what is critical here is empower the engineering team and make sure that there is an approach so product managers or product people can engage early in the development to have all the insights captured with the business and the customer, and provide quality product requirements for the team keep going with the contract, or maybe another subject matter expert in the company that is going to implement the contract. It depends, but yeah, I mean, it can be done.
Right. Okay. Thank you. So now, next question for Samy, related to our AI advancements. So, what is the risk of using AI APIs on my data?
Yeah, so that's a pretty common question, and so usually AI APIs providers don't save users' data. So that's what they say, at least. If it's very sensitive data that you don't really want in the cloud, so you cannot use APIs for sure. But usually also have a second option, but it's not. It may be 1% of the providers that propose it, that they provide you with a Docker image or something that you run on your own cloud. But it's not usually the case for everyone. So you must trust the AI providers. You're gonna sign contracts, privacy notes, etc. But yeah, usually providers don't save your data. So if it's really sensitive, then you might not even send it to the cloud. Then it's not possible to use APIs. But either ways, it's you lose the advantage.
Yeah, that's true. That's true. Okay, thank you, Samy. Andres, two-part question here for you. In the standard case, what is the format that you would recommend to use for saving information? Yeah, the next part after this.
Let's start from the beginning. I suggest it's not the common answer like it's depend, because when you save information in external mechanism of cache, the size is so important for us. So I recommend that you compress the information before to send to an external database. For example, if you use Redis or Memcache, you pay for the space of memory that you use in some cloud provider. So if you try to compress and reduce the size of each row that you insert in the database, you pay less money. So as a suggestion, try to compress. You need to create some kind of mechanism to compress the information. Like, okay, perhaps I can transform the object that I want to save in a JSON format, and after that I can compress the information, and I need to create a decompress mechanism when I obtain the information from the database. Of course, the cons of this is when you try to check in the Redis or Memcache the information, you have everything compressed, so it's so complex to find some kind of information, but you pay less money, and of course it's a mechanism of cache, so there is nothing that is so relevant to save it in a mechanism of cache. So this solved the first part of the question.
Yeah, and the second part, how you handle the schema changes of the information.
Here you have two alternatives. First one, if something changed drastically in the information that you save in the mechanism of cache, you need to create some kind of mechanism to invalidate the information or reload the information. But I suggest that it's more simple that you implement a mechanism to invalidate, like, I don't know, listen an event from the API that have the information, and these events say, okay, something changed in that row in the database, please invalidate that information in the cache. This is one alternative. Another alternative is like detect the change and upload to the mechanism of cache. But in the case that only change the information, like change the one attribute, in the case that you change the entire schema, and you have two alternatives. One is invalidate because perhaps you change the level of the attributes or the structure. So perhaps when you try to obtain information from the cache, everything throw an exception. And the other alternative is like create a way that you can do a background compatibility. So in the case that you have the old model or the old schema, everything continue working, and if I have the new one, also works. Increase the complexity. I suggest like invalidate and reload all the information.
Got it. Okay. Thank you. Raymond, now talking about how not to API and the API first approach. I wanted to see if you have any suggestions or best practices regarding API first, which means that we are starting defining the API from the beginning as part of the requirement. How you enforce that all the teams, all the devs follow a certain, if you want, definition of how the API should be, so we don't have different versions of the truth.
You have to have product management on board to actually enforce that. And that means they actually need to care. In developer relations, I've had to make the case that, yes, one API is using max and one is using total. The product management are like, I asked them to build a feature that let them limit how much they could return. They did that feature. I have to make the case for consistency and what it means for a developer, and the product manager has to be on board. If you don't have someone outside of engineering, I would say, who's managing that and making sure that they're not just fulfilling the contract, but they're actually doing it well, doing it consistently, then you won't have it.
Got it. Okay, I know that we have a lot of questions. I have a lot actually, but we are running out of time to let people have time to take a break, because we went from one block to the other without coffee. So probably a lot of people is dying already. So I really thankful for the time that we enjoyed all together, guys. I hope all the attendees also appreciate all the information that the team shared here. We know that APIs are really important, and these days are the product. No, APIs are our product. No, so I will let you each of you say goodbye. Let's start with you, Andres.
Thank you.
Yes, thank y'all.
Okay. Thank you, everybody. See you.
Thank you. Bye-bye.
Okay. Okay, let's go to a break of, I believe, just 5 minutes of break, team. So let's wait for our next block. Bye.
Hello and welcome. My name is Andres Sacco. I'm be the moderator of this section of the conference. And now I will present you Deepa Subramanian, which give you a talk about how to cook Fugu's API. Hi Deepa, how are you?
Hi Andre, thank you so much for having me here. It's 6:20 in the morning, so just woke up. I did have my coffee, so that's good. So
okay.
Hello everybody. I just want to get started, and today we'll be talking about how to cook Fugu APIs. Do you see my screen? Yeah, cool.
Yep.
Thank you. Okay, so before we get started, I just want to introduce myself. My name is Deepa Subramanian. I am a Google developer expert for web technologies, and I'm also an ambassador at Women Tech Makers and an organizer at Google Developer Group San Jose, California chapter. And here is my QR code for all my handles, and every slide would have my LinkedIn handle at the top right. And fun fact about me is I love coffee. So let's move on. Today, the agenda is going to be, I've just split it across into several topics. So I just wanted to start off with, because this is a beginner level, I'm assuming that you do not know anything about Project Fugu. So the agenda is going to be, we'll start off with what is Chromium browser and how Chromium and Project Fugu is related. And we'll talk about some of the Fugu APIs and its implementation, and what's new with Project Fugu, and we'll wrap it up with a Q&A after the session. I believe that it's going to be after an hour. So before we get started, I just wanted to set the stage here. What is Chromium browser, right? Chromium Chrome is built on Chromium browser. So it was initially developed by Google, and later a small community joined and started contributing it. So it's an open source project that is managed by the Chromium team at Google. So you could say that Chromium is a subset of Chrome, right? So these are very common Chromium-based browsers where you have Chrome, Electron, Edge, Microsoft Edge, as well as Opera is also one among them. So now moving on to Project Fugu. What is Fugu, right? So Fugu means in Japanese, it's a pufferfish variety, and it becomes a food when it is cut in a certain manner and cooked, and it becomes a delicacy. But however, if you cook it in the wrong way, it can become fatal to humans. So likewise, Fugu APIs must be used appropriately, as it could be a threat. So Project Fugu comes under Chromium project, and it's also open to all Chromium contributors and organizations, right? So what does Project Fugu aim for? Project Fugu is mainly, it's an effort to close the gaps in web capabilities, enabling new classes of applications to run on web so that people can build great experiences around the web. So who are the companies involved, right? It's a collaboration between Google, Microsoft, Electron browser, Samsung browser, and then Intel. Intel, why Intel? Intel is not a browser, they don't have any browser, but Intel makes about 60% of hardware devices around the world. So Intel is also involved in this collaboration with Project Fugu. And if you take a look at this, what are the APIs that is, if you go to Fugu Tracker, there are a bunch of APIs that has been already shipped. There are some of them are still under a developer trial, and some are still in consideration. You could also join this forum, and there are about 50 to 55 APIs that has already been shipped. And if you want to try out the new ones, you can also use the developer trial, which can be found behind the Chrome flag. And there are several more APIs under consideration, right? So you can also visit this website, Fugu Tracker, to know more about Project Fugu APIs. So now let's move, let's shift gears, and we'll see what are the Fugu APIs, right? So I will be talking about these APIs for today, but there are so many more. But I thought, okay, I'll just pick up the ones that is very widely used and that you might be familiar with as well. So before we dive into this, we'll start off with the very first one, which is a service worker API. Service workers are special type of web worker APIs, which has been around for a while now. So these are APIs that run separately as a separate thread against your application. Service worker interface provides a reference to a service worker. And this API is commonly used for building progressive web app, where it acts as a network proxy, handling all the requests and response. And note that this API could also work with other APIs such as a background sync, notifications, and basically it does a background sync. So that this has been around for a very long time now. So how do you implement this? First, you need to register as a service worker with Navigator interface. And then service worker goes through a life cycle. Once you get it registered, it gets installed, and it listens for events, and then it activates based on that. So understand that this goes through a life cycle. If you want to know more about it, I have a progressive web app talk as well. I've given it at Geekle too, so you can check out those videos. So this is something that I wanted to mention. There are a lot of APIs that may or may not be supported by different browsers, right? If you see on the left, these are the platforms and the browsers that APIs support. And on the right, you have this mobile browsers too, the ones that you found it on the phone. So if you see most part for this API, everything is in green. So it has been supported by a wide variety of browsers as well as platforms. So understand that whenever you are trying to use Project Fugu APIs, either you programmatically check whether the browser support is there, or you could also go into this website called as caniuse.com. So I can pass on these slides, and if you click onto these images, you would be taken directly to the URLs as well. So now moving on to the next API, it's Web Share API, which by its name it implements that it provides a mechanism for sharing text, links, files, and etc. Right? If you see at the top of this image here, you have a cat image, and if somebody wants to share, you use this API, and it uses something called this navigator.share method, where you could share the title, text, or the URL, and then based on what browser you're using and whether it has support, you can share it with native system application. So once you open this, the share options come up to you, and then here in this case it says Gmail, and then Gmail opens up. So this is something. This is exactly how it looks. This is a demo. If you go to share a web share API in Google's blog, you would see this demo, and I took a screenshot of this. So how would you implement this, right? So this API has two methods. One is navigator.canShare and navigator.share. So if you want to make sure that you want to share, you can use this canShare method first, and then you could say navigator.share. Right? So if you use this mechanism, and it will open up the underlying operating system, and it passes specific data. Here we are sharing the details such as URL, text, and title. So make sure, and also we are having a callback mechanism saying that, oh yeah, if this if this method is not supported, we also have something to say, hey, it's not supported. So this is what I was trying to say, that it returns a promise, and if the data was successfully sent to the shared target or not. So make sure that you handle whether the browsers can support it or not with a fallback mechanism. And again, this API is, if you see on this lighter green ones are still in experimentation. So although the darker green ones are supported, so if you see Edge is supported, Safari is supported, and there are mobile browsers that support this Share API as well. So moving on to the next API, we'll talk about Screen Wake Lock API. Like its name suggests, it prevents from dimming or locking the screen when the app needs to be continuously running. So think of it, the examples would be if you're using a web-based presentation app like this, right? Or a kiosk, you go to a store and where there's a kiosk present there, and where you have to order items, and you don't want the app to go you don't want the app to go on sleep or something like that. So that's one of the options. And there are some other examples that I could give. There's one more. It's a recipe application where people could, keep the screen on and lock the API, lock it using this API, and they can have this application running. So there are 3 steps to implement this API. One is, first you need to request wake lock. And then once you're done, you have to make sure that you also have a implementation for releasing the lock. And if the user wants to relock it again, then you have to reacquire the lock. So these are the 3 steps you would use for implementing the screen wake lock API. So here's an implementation. If you see, the wake lock request method is a promise-based, and so we can create a asynchronous function which in turn updates the UI. So here we are saying that, okay, if it is, then you have to activate the screen, right? So and it reflects the lock and sees that, oh, okay, let's activate this, right? And make sure that if it's not, for example, if you're working out of a laptop or if you're using a mobile device, in that case, you also need to handle error messages that are related to battery, etc. And then how do you release this lock? Using wake lock.release. So and then if you want to reacquire, it's the same thing, where you can add an event listener and to listen the changes and reacquire lock using the same method that we used before, which is wake lock.request. And here's an example. This is an example that I picked up from Google's blog. It's called Betty Crocker, where if you see in this, there is a toggle button that says keep the screen on. There are 2 of them here. So once you enable these, it's supposed to keep this application running at all times until you go turn off this toggle. So again, what are the support here? It's widely supported by most of the browsers except Firefox here. And we'll move on to the next one, which is the Contact Picker API. So it provides, like I said, like it says, you can share contacts from the contact list, but make sure that this is this API has to be used with care. Whenever you are trying to select a contact, only one of them should be selected. So this has to be handled with care. So when would you use this? For example, you want to send a message via an email, or you want to share your contact with social media, etc. In that case, you would use this. And navigator.contacts is an interface that returns a contact manager object instance, and which in turn calls this select method to provide the contact details. So that's how it brings up all the information. So here is an example. This is again from one of the demos in the blog. So if you see, you can select multiple. This is on an Android device that I took a screenshot of. So you can select multiple contact. What are the things that you want to use for picking up the contact? So I selected most of them, and I did this. Chrome is asking me whether I should allow to access these contacts or not. So note that when I do that, it is only selecting one of the contact that is there. So that's something that you might have to consider when you are using this API. So there are other ways. This API is still under experimentation. If you see here, I picked this up from MDN. Note all these browser support can be found in different places, either in Chrome blog, or if you go to MDN, or you can use Can I Use as well. So if you see, there's only support for Chrome Android, and there are some other Samsung Internet and Opera Android as well. So none of the other, if you see the desktop platform does not support this API yet. And it's still under experimentation. So now moving on to badging API, this is one of my favorite ones. I use it all the time on my phone. So it provides a way of setting a badge on a document or an application, and it acts as a notification that would just let the user know that it has that the state has changed without displaying more distracting ones. Like, I don't like those alerts or alerts that pops up on the notification tray. So I like to have it as badges. So these are some of the ways that you could also implement this. So if you see, there is this has been supported by Microsoft Edge, Microsoft as well. If you see, Microsoft has this is an example from Twitter and one more app. And if you go to Project Fugu's documentation, where you can download this this particular demo app, where you can give where you can set the app badges to be, and then once you install this, it would show this app with the badge as well. So also browser tab, if you have noticed, if you had gone to Facebook or Facebook Messenger on the browser, sometimes it shows up the number of messages that you have received, or posts or feeds. So this is something that it can be used for inside the browser as well. Again, how would you implement this? You would use a method called setAppBadge, which is very evident where you can set it. And then once you have it, when the user visits the page or visits the app, you have to clear the badge. So this is something that I wanted to show. And these methods are supported by, if you see, mostly the support is for mobile, and there's some of them are still with Chrome and Edge, which is still in experimentation, right? So moving on to the next API. So we'll talk about File System Access API, which allows files and folders that the user can select from the operating system itself. So you can, what are the use cases? You can open a local file to read, edit, and save, or you can open a local file to edit and autosave with autosave, and you can create and save as a new file, or you can also delete. So this has to be, again, handled with care, because you're dealing with files inside the operating system itself. So here, if you see, we have to mention what are the acceptable types when the user if they want to use a file from the system, from the operating system, or from the device. So you have to mention what is the type that it can accept. Not all files can be accessed, so that it does not get accidentally deleted, right? So here is, we use this method called window.show open file picker, and it opens and it lets the user choose the options here. So if you want to create a file, what you would do is you have to use you can use create writable method, and then you can save it using window.show save file picker. So that way you can save, and make the note that here we also have to say what is the acceptable type of this file, right? And this API is still under experimentation, because not every browser vendor or platforms are willing to, or they don't want to take a risk off. So it's still under experimentation. However, if you want to check out, or if you want to, there are a lot of demo apps that are available that I will share it at the end, so you can check out how it can be implemented. So there are so many more APIs. I think you might be familiar with these: push notification. There's also shape detection, which has text, face detection as well, and QR code detection under shape detection API. You have web USB, payment request API, geolocation, and there are different ways of handling files. There's an API for that, web Bluetooth, and then app shortcuts. You can have eyedropper API and web OTP as well. There is, like I said, there are a bunch of APIs that have been released, and there are a bunch of APIs that are still under trial, and there are a lot more to come too. So, Project Fugu enables new experiences on web. However, it preserves the core benefits of web based off of security, low friction, and and it's also available in cross-platform too. So all Fugu API proposals are made in open and on the standard tracks. So if you want to see what is the status of Project Fugu, you can visit this website and see what is the status around this and what are the APIs that are yet to come. You could also submit your own proposal here. So to get involved, you can get involved and do experimentation as well. But however, you need to register for those. So I said that there are some of the APIs that are still available behind the Chrome flag. So you would probably use this flag inside of Chrome and say enable experimental web platform features. These are some of the trial APIs that are still underway. It is not shipped, so if you want to take advantage of it, you can go probably experiment with these. And there are something behind trial. These are new APIs that people want to have in web. So, however, you have to go register for this, and not every proposal gets accepted, but that's something that they have a process for going through each of the proposals and see whether it can be implemented or not. So I did say that at the beginning that if you want to see what are the apps, there are a lot of applications that uses Fugu APIs. If you go to this Project Fugu API Showcase, a website, and you can also sort by the API that you want to. There's a bunch of them that has already been used. And if you see here, there are some listed as well. So you can go take a look at it. And if your application needs one of these APIs, you could go see how it can be implemented, right? I did say about, you can see in different websites where you can go check out either Chrome blog or NDN docs, or you can also go to caniuse.com to check whether the API is supported. But if you don't have the patience, you can also go to this website called whatwebcando.today. And if you just open this URL, and it'll give you right away whether your browser supports these features or not. It says here, so this is from my device here. I have a Mac OS, and this was in Chrome browser. It says that, yeah, local notification, push messages, etc. is there. And some of them are not there. So for example, inter-app sharing is not there. And I can also, NFC is not there. So these are some of the things. And if you see, contacts is also not there. So you can go check out if you want to just go visit what are the support that you have on your browser, right? So what is the future of Project Fugu? Web has more capabilities. There are a lot more APIs to come. And most of these APIs are still under experimentation. Not all browser vendors support these APIs. So let's cook this new Fugu right? So that's something that I wanted to say. And if you go to this YouTube video, there are a couple of things that are announced during Google I/O. They still have file handling, and there are some of the applications that use Fugu Advanced API as well. So I have a bunch of blogs about this on my Medium. If you are a person who doesn't want to watch video, and if you want more detailed implementation or how it's being used, I have blogs for this. So you can go take a look at it if you want to. And so far we covered what is Chromium browser, how it's related to Project Fugu, what are the companies that are involved, and we did talk about few API implementation and more about the project itself and the direction it's taking to shape up. And if you have any questions, we'll come back to the questions session. And thank you so much, Geekle, for giving me this opportunity. And thank you, Andre, for having me, hosting me here. And I have shared my slides if somebody can share it, that'd be great. And thank you, Nick, for having me here again.
Thank you, Deepa, for your talk. It was so interesting. I have some questions for you in the QA. Now, no, because it's time to have a short break before our next speaker, who is Kundan. So thank you. And all the people that have any question or doubts, please write the question. And at the end of this block, we will discuss all the questions with Deepa and with the other speakers. You are mute, Deepa, sorry.
Sorry, I shared my slides, and if anybody wants to take a look at it, they can. Thank you.
Okay, we have a short break, and after that, we have our next speaker. Hello again, and it's time to have our next talk with Kundan Karma. Hi, Kundan, how are you?
Hey, Andres. Hi, good morning, good evening. Hi, everyone.
Kundan have a lot of experience with machine learning, have a lot of experience with different topics. He give a lot of talks on different conferences. And today he will present to us Azure OpenAI and Cognitive Services API, low-code, no-code AI solutions. So Carmen, is all yours, the stage. So let's start with your presentation.
Yeah, thank you very much. Thanks, Andres. Let me share my screen and get it started. So hi, everyone. Good morning, good evening, good afternoon, wherever the time zone you're joining. And welcome to the session. Let me share my screen and get it started. Once people can see my screen. Andres, can you see my screen?
Sorry. Yes. Yeah. The presentation appeared in the talk, so everything it's okay for now.
Hello?
Yep. Hi, Kundan.
Yeah, okay.
Yep. We will see your
Thanks for confirming.
browser.
Yeah. Okay. Perfectly
So let's
fine.
start with the presentation.
Hey, everyone. Okay, you can see my screen, right? Okay. So let's get started. So here I would like to talk about the Azure OpenAI and Cognitive Services. This session on that one. So people without having or very low knowledge having on AI, they still can integrate the artificial intelligence into their applications. So first, before moving that, let's understand what exactly the AI is. What is an artificial intelligence? That will help us to understand better this session. So the artificial intelligence we can talk about, it is a branch of computer science that mainly focus on creating intelligent machines that are capable of performing tasks that typically require human intelligence. So the human with their intelligence, whatever the tasks which we do, to mimic the task through the machines, there's a branch of computer science called AI, which is in place, and the intention of that branch is to help us and do the similar things which the machine can do, which the humans can do. So AI systems are designed to analyze data, recognize patterns, and make decisions or take actions based on that analysis. So AI algorithm can be trained to learn from large amounts of data and improve their performance over time, because AI is not a magic. So actually it learns from the historical data. So as much as the data, historical data is having, from that data, from that insights, the machine learns, and it helps us to anticipate or predict or forecast the future decisions. Okay, so let's understand what exactly the difference between AI and machine learning. So machine learning is a subset of AI. So AI is like a whole superset, or it's like a big giant. We still need to reach there, but ML is the one which is so powerful and the proven, and it is getting used in multiple places. So machine learning is a subset of AI that involves the development of algorithms that allow computers to learn and make predictions or take actions without being explicitly programmed. Okay, and the deep learning, many people talk about the deep learning. So that's the reason I put this slide here, so we can make a difference that can help us to better implement the AI into applications. So deep learning is a subset of ML that uses neural networks with multiple layers to process complex data and extract meaningful patterns. So it utilizes the artificial neural network instead of conventional algorithms to create the AI models. Okay, so let's understand what exactly the flow of creating the machine learning, and then only we can understand like how easy is to use the APIs instead of making the whole end-to-end AI solution. So in order to make an AI or machine learning solution, the typical workflow is you should have a first problem, what problem you need to solve. Then based on the problem, you go and collect the data relevant to that problem. And then once your data is in place, and you as much as data you have, as better your the model will be for prediction. So collect as much as data from history, and then requires the data once whatever we get. Sometimes the data is structured, sometimes unstructured, sometimes semi-structured. So we need some pre-processing, and sometimes the data has many null values, outliers, and so many things. So we do always pre-processing of the data. And then after that, it requires some transformations through the data, changing one values to another value, like categorical to numerical, or merging multiple columns into one column, or doing some calculated columns. So it requires some transformations of the data. Then you need to choose an algorithm, which algorithm will be useful for creating the machine learning model. And then based on this model and the data, the final transformed data, we can train the machine learning model. and that training takes time. Depends upon the amount of data and the is it a machine learning algorithms or deep learning algorithm, depends upon that. And once you have a trained model is in place, we always go ahead and evaluate the model and try to optimize the model, like setting some hyperparameters or so many other techniques by which we go ahead and makes the model better and better. So I'm not going into much detail, but there we do for all the kind of an optimization to our model, and then finally we test and validate it's on the some other data set which is model has never seen it before. We always go and test and validate, like is it performing good or not. And then final our model is in place, we take the model, we deploy. So deployment can be different, depends upon the type of application. Like if you take an example of a sentiment analysis or entity recognition or image analysis or any such kind of a thing, where you can deploy the model as a service like an API. And here once you deploy you as an API, anybody within your organization or outside of the organization, that people can use that model as a service. So people don't need to follow the whole process here up to here. People can directly connect to your model as a service through an API, they can use it. So this process is required to create a model and to make it as a service. And then finally, once if you created a model, you always put some kind of a telemetry diagnostic. The monitoring is in place, so you can troubleshoot it easily, and you need to maintain that model into some place so that version control can be done, or all the other necessary things which requires engineering hygiene. Apart from that, sometimes because data keeps on coming and a different type of data you need, sometimes new data sets been introduced, so maybe the model which you might have created may not be enough. So you always do iterate your model again, iterate the whole cycle. You go ahead and do the same data or collect the new data or some addition to data in for the life cycle of any machine learning model building, and this model can be deployed as a service. So what Azure offers, right? It actually offers directly some of the models which are commonly used by the people into their application as a services. So let's see what kind of advantage it brings. So suppose if I ask you a question, would you now after all of this, or based on the problem or based on the application you deal with, would you like to incorporate the artificial intelligence in your application? Yeah. So suppose if you answer this question, then if you are not suppose belongs to the artificial intelligence background and you don't have any experience, then you may ask somebody else in your team or somebody in your org which actually helps you to build the machine learning model, and that you can integrate in your application. Or another option is you can start by yourself, right? That requires some learning curve, and you need to ramp up yourself into all this ML, data science, and data engineering, all this culture, and then you can do it. That is little time consuming, but still you can do it. You must be super excited but don't know where to start. That is also one thing, because it's a big area. So another is this is also one kind of valid question, like you don't have any interest into AI at all, right? You just want to stick with your technology, and you want that like somebody else will do this kind of a work for you. So yeah, keeping this all things in mind, that the cognitive service and an OpenAI service has been launched. So you can easily solve your regular AI problems, most of the AI problems, by just calling a service. Okay, so let's understand what is Microsoft Cognitive Services are. So Microsoft Cognitive Services is actually the collection of cloud-based artificial intelligence services provided by the Microsoft Azure. These are ready-to-use services. It allows developers to easily incorporate AI capabilities into their applications without needing to build and train custom model from scratch. So as I told, what kind of a life cycle any AI model is having, if we need to build a model from scratch, everything you don't need to go through. Just you need to call that whole AI capability or the models only using the API call. So you can save much of your efforts. Okay, and now it offers a wide range of APIs and services, such as it offers the services into computer vision space, like image analysis, object detection, and so many things. Speech, the audio track of it, where it is speech to text, text to speech, all this kind of services are available. The language APIs, where just like entity recognition or and sentiment analysis, classification, all this kind of things can be done, and some decision making things like anomaly detection. All this could be possible easily by using the cognitive services. The vision APIs actually help us for multiple features like object detection, face detection, and recognition, and image analysis, and OCR, optical character recognition. So if you have documents and if you need to scan the documents and you need to store it as a regular text from that scanned documents, then this APIs will help us for all the kind of an scanned document, it extract the right text out of it. So these APIs are available. The speech APIs like speech to text, text to speech, conversation can be done, and the language translation as well. Like we have multiple languages in the world, so if you need to convert text from one language to another, and that can be truly possible using the cognitive services APIs, like Spanish to English, English to Spanish, Hindi to English, or many different translations could be possible. And there is a language APIs which actually gives us all the NLP capabilities, such as text analytics, sentiment analysis, language understanding, language translations. All these things can be possible. Apart from that, actually, the cognitive services help us to build the chatbots and virtual agent as well, using the language understanding intelligence service, the LUIS, and bot framework. So using that, we can create a virtual agents or chatbots, and this chatbot we can integrate directly into our application, or that chatbot does not require any kind of a training of the model behind the scene. Now, the most important thing is all these cognitive services we can access through the RESTful API interface. There is no kind of a much effort. So, irrespective of the technology which you are using, through this REST API, you can use the cognitive services easily. Apart from that, some SDKs are also available. Depends upon different language. So, based on the different languages, you can utilize the SDKs, and then using this SDK, you can call these services. The services are in Azure, so the benefit of that is the scalability. You don't need to worry about the scalability. It can scale based on the usage, so you don't need to worry about the performance. Reliability, because it's reliable, officially provided by the Microsoft. So it takes care of all the responsible AI and the securities and all these things behind the scene. So it helps in that way. So these are the important links which has the cognitive services details, and then there is a how to start and how to use cognitive services. Step by steps is provided in the second link. Apart from that, the third link is all the GitHub samples which help us to ramp up yourself and use the cognitive services that you can use from these three links. So how to create the cognitive services into the Azure space? So you first need to log into the Azure portal. If you don't have an account, you just create an account, and after that, within that, you can procure the new service, and we can call it as a search, like a Azure Cognitive. Provide your subscription, a resource group, the region on which you need to get the multiple regions be supported, name of a service, and the pricing tier you can select, and then you can create it. So that way, once this is created into the Azure portal, then you can go ahead and start using from your local environment, online environment, or from anywhere. You just need a subscription key and the service name, and then you can start using it. Okay. So yeah, that's about the cognitive services, how we can use them. Another track is the Azure OpenAI service that is recently been introduced along with the cognitive services. So all the services are based on the OpenAI models. So now more and more people are making use of the ChatGPT, which is available, and it is one of the phase shift into the whole search industry. Now it can answer us in a more meaningful way, and our search become more kind of a focused one. So all this the offering which is provided by the through the OpenAI ChatGPT, it is integrated in form of the services through Azure, so that we can go ahead and use the capabilities of GPT through the Azure. So let's understand. So what is exactly the Azure OpenAI services? It is a service that provides the REST endpoint to OpenAI's powerful language models. So as I told, like OpenAI is the company who is the owner of the ChatGPT, and it created multiple different models behind the scene to power the ChatGPT. So through the Azure OpenAI services, we can get an access to that models, and we can utilize that models through the services into our applications. So that has been possible here. Now these models, there are different type of models are works behind the scene of the ChatGPT. The GPT-4 is another model, GPT-3, Codex, embedding models. So there are different type of models. So we'll understand each of the model one by one. I will go through that. But these are the models which works behind the scene. So it enables new reasoning and comprehension capabilities for building cutting-edge applications such as writing assistance. So whenever you would like to write an essay on any topic, you just tell the GPT service or OpenAI service, like this is a topic on which you need to write an essay into 500 word, 250 word. It actually helps us to do it. And many people might have experienced that one as well through the ChatGPT interface. Apart from that, you tell us what exactly the problem is, and tell the service to write a code in any language of your choice, and it will go ahead and write a code for you. Reasoning over data, you provide your data, and then you ask the questions on that data, and actually it answers of your questions based on your data. It allows the user to customize generative models with labeled data and hyperparameter for their specific scenario using simple REST API or web interface. So here actually not only it is answering the generic questions, but actually you use this the services available, and then you can make use of your own data set as well. So suppose you have some domain, very specific domain, suppose the oil and gas industry, electrical industry, or kind of a manufacturing industry, or any kind of the IoT industry, where maybe having their own custom domain, and they're having their own terminologies to use. So you can use the services and customize the services, like we call it fine tune this model on your data set, and that then you can utilize this to answer the questions which is specific to your scenarios and the organizations. It has built-in interface to help ensure responsible AI. Because it is powered through Azure, so you don't need to worry about some basic but important characteristics and the feature. One is the responsible AI. So all this the AI services which has been available, the result it brings, taking care the security is in place, proper content filtering, and content and the modernization and the implementation guideline. So all this, which is a part of a responsible AI, been taken care to services. So you don't need to worry about it. Like a scalability as well is one of the important feature which Azure provides. Apart from that, the most important is the responsibility of the results, whatever we are getting. It should be adhere to all the compliances, and it should have all the securities in place, and it should not bring any inappropriate content. So all these things been taken care by the Azure. It runs on the Azure global infrastructure with enterprise grade security, compliance, and regional availability. So you don't need to worry about the scalability, you don't need to worry about the security, you don't need to worry about any compliance, and you don't need to worry about any kind of downtime. Like if one region is down, another region is available. Like a disaster management system, if you need to create, that requires a lot of money and then efforts as well. So you don't need to worry about all this thing if you are using an Azure services. Okay, so because I park one question about different models which OpenAI provides. So this is one kind of interface I use of Microsoft Bing, and through the Microsoft Bing this is provided, and this chat is powered by the OpenAI's ChatGPT. Along with the result from ChatGPT, rich experience. So here I just ask the question: what are the models that is supported by Azure OpenAI? Services. So now it's a model. Actually, it is not a model; it's a series of models that can understand and generate natural language, and this includes the new ChatGPT model. So it has multiple models in this place that help us to understand the language which we are talking about and the question which we are asking, and based on the question, it will get the relevant content for us and present to us. So that's the models behind the scene. The DAL-E model, this is another series of model that can generate original images from natural text. So you can think like if you ask any question to generate any kind of an image, like which is in your mind. Like suppose you need to generate one image, like the dog is eating the toast. Okay, please generate an image of that. So it will generate the original image based on your text of description. So what is the description you provide? Based on your description, it will go ahead and generate the image out of it. So that has been powered by the DAL-E models. Another is the code. Like suppose if you need to write a code, right? You can write a code for a Fibonacci series. Okay, and write a code for the write a code binary search tree, or any kind of an problem you provide, and write a code in C#, write a code in Python, or any language, whatever you provide in your input. Based on that, it will go ahead and generate a code for you. And many people might have experienced it, generate a very beautiful code to be used in your application. So all this is powered using the model. And apart from that, there's an embedding, which is specifically the concept which is more related to the machine learning model. So embedding, in short, if I explain, embedding is nothing but actually it converts your natural language into the numerical vector. So all this model is a set of models that can understand and use embedding, and embedding is a special format of data represented that can easily understand by the machine learning model algorithm. So all of your data, natural language data, will be converted into a form which can be easily understood by the machine learning model. So this embeddings is in place. This is one of the powerful things, embedding, because a machine don't understand the natural language which human talk. Machines only understand the numerical things, the numbers. So this is a layer which can help to convert your natural language into the numerical vector, so that the machine learning model or AI model or the machine can understand it well and use the right result. This one, this is the recent one, which is one of the most powerful as of now, that the transformer model is in place. It is the advanced model, which a set of model that improve on GPT 3.5 and can understand as well as generate. So this is one of the advanced model which came after GPT-3, GPT-4, which has a capability for both natural language and the code understanding, and is much more powerful. You can read more about it. Okay, these are the same description which I provided, and here is the I just put it for your reference, so you can use it. And this is all I generated and with their reference as well. Okay, now let's understand how we can use the OpenAI service. So Azure OpenAI service we can use similar. We should go to the Azure subscription, Azure portal. You go ahead and provide a subscription name, resource group name, your region where you need to create, and nearest region to you, and then the name of the service, Azure OpenAI service, which you need to give, and then the pricing tag. But apart from this, the most important is before doing this thing, because these are the recently launched models and the services, you need to take some pre-approval. So there is one form which you need to fill, and after filling that form, based on the region which you select and based on your need, you will get an approval, and you can start using the services. Okay, now how to deploy the model. So once we created this is one extra step, then the cognitive services. In this one, after creating the service, you get access to one special studio called Azure OpenAI Studio. In this studio, you can go, and then you can because the list which I provided, different set of model. All these models you can go ahead and create deploy model of them, each model of them into your subscription, and then you can start using them through the REST API endpoint. So this is the kind of an look and feel of any Azure OpenAI Studio, and you can see we can do multiple things here. The queries and so many advanced with fine tuning based on your custom or domain knowledge. So yeah, this is a kind of an OpenAI Studio, and then once you go ahead and to the model side of it, and then you can create the model, and there are different types of model which you can create and keep it here, and that same we will use it. I will show you the demo. So let's jump into the demo part of it, and then I will show you how easy is to use it. So we'll start with the cognitive services. So I'm just a couple of the through the Jupyter Notebook and the Python, but it is not limited. Azure Cognitive Services and the OpenAI, both you can do using the any language because these are RESTful services. You can use any language to call them. Okay, so let me get started. So this is some libraries which you need to import. These are all I kept my secrets. So secret is like once you go to your Azure portal, you can get the cognitive services key and the endpoint, and both you can use. I just pulling it from my some file where I kept my all the endpoints and all this thing. So now after that, you need to create a. I'm using a through the API. I'm using its SDK. So I install the Azure.core and Azure AI Analytics libraries here, so I can directly use using SDK. So here I'm just creating a client of it out of it and provide an endpoint and the credentials which I get it. And the credential is based on the key. And once we get it, like suppose let's see, like I want to try the sentiment analysis API. So suppose I written that I love using Azure Cognitive Services for text for sentiment analysis. Let's see how is my sentiment score and how is the machine feels about my sentiment. Then once I call this API, I got a response back. So this is my response back. This is the response it looks like, and you can see here, and these are the score. Like how is my text look like? So it says 1.0 means 100%, right? Its score is from 0 to 1. So my text is a positive, 1.0 is a score, and it's not a neutral, and it's not a negative text. And this is the text which I written here, and then it provides me the scores as well as the positivity back as well. So now this is the confidence score of my text based on the sentiments. Now let's try another text with some negative sentiments, like suppose, and here I just try, I'm totally disappointed with your performance, just like a single tagline I put. And now if you see here, here whatever we printed is it is not a positive text, it's not a neutral, it's a negative, it's a full negative text, and it gives us the result like that. So you can totally use this way, and based on it has multiple applications. You can integrate this as a plugin to the Outlook, you can integrate as a plugin to your virtual assistant. So before or if you are as a kind of a social media text, before somebody write any kind of post or any text or in writing an email, they should understand like, okay, what is the sentiment before sending it. They should know like their tone, what tone which you're talking about. And apart from that, it is a good useful case for the customer service. Whenever the call centers or customer service people call, or when the people write an email to customer service, then they, based on the tone, they can understand how much the sentiment is behind that the email or the text. So they can, based on the sentiment score, their queries or grievances can be prioritized. So apart from that, another example which we need to bring is entity recognition. So within the same stack of cognitive services, we can use another one feature called entity recognition. Same, I use this text, and I say Microsoft was founded by Bill Gates and Paul Allen by Bill Gates and Paul Allen on April 4, 1975. And this is a text I written, and let's see like how the response comes. So here we are using different kind of an here we use client dot analyze sentiment, and then here we use client dot recognize entity. So this is a different API function I'm using, and then based on the different function I'm passing my text, and then let's see what the response come. And here I'm printing the text whatever I put it, and then the categories of the text of especially I'm interested in finding all the entities and the category of that entity, and there is a confidence score by which it has been recognized. So I can see like it is going through my text, and then it is finding all the entities, and what it found is a microservice one entity, and the category is an organization, microservice organization. This is a confidence score of 100%. Another is a Bill Gates, it's a he's a person, and then confidence score is printed. Another is also Paul, he's also person identified, and one more thing is a date and time is identified, it's a date time. So based on your text, like suppose if you have a big text of whole pages or something, you need to identify the right entities out of it. You can utilize this kind of an APIs for that one. Similar, like I just written one, like the Mona Lisa is a painting by Leonardo da Vinci. That is
Hi, Kundan.
in the Lawrence Museum. Yeah.
Unfortunately, we don't have more time.
Hello.
To your presentation. If we have any doubts on the audience, write your question, and we will go within the QA to discuss more in detail about Azure OpenAI, and if we have time, we discuss the examples, and because we have our next speaker waiting to the conference. So at the end of this block, in just a couple of minutes, we will discuss everything about this talk and the previous one. And if again the questions, please write in the chat. Thank you, Camden, for your talk. Okay. Bye, Kundan. I will see you in a couple of minutes.
Yeah, thank you very much.
Okay, it's time to present our next speaker, Sidney Maestre. Hi, Sidney. How are you?
Fine. How are you doing this morning?
I'm fine. I'm sick, but I'm fine. Okay. Sid is a VP Developer Relation and APImatic. He is speaking on different conferences related with topics on APIs, of course. He worked with companies to automate the way that they build developer experience and drive the adoption of the new APIs through SDK. So the idea of the talk is OpenAI best practices for generate SDK. So Sid, the stage is all yours. You can start with the presentation when you have time.
All right. Thank you very much. And thanks everyone for joining today. I'm going to share my screen here real quick. So let's just do the entire screen. All right. Yeah, so as he mentioned, I'm Sid Maestre. I work with a company called APImatic, and our product is designed to help API creators, API producers, to automate how they generate SDKs and drive developer adoption of those APIs. And so today we're going to talk about what are those best practices around your API definitions so that you get high quality code libraries and documentation from those definitions. But before we get started, we really need to talk about Indiana Jones and Raiders of the Lost Ark. Probably one of the best adventure films ever made. It's definitely one of my favorites, a collaboration between Steven Spielberg and George Lucas, starring Harrison Ford. Now, early on in the plot of the movie, there is a headpiece for the staff of Ra, which is going to help our heroes find the lost Ark and its location in Egypt. So Indiana Jones travels to Tibet to meet up with Marion, who he believes has this headpiece for the staff of Ra. And on it has some writing that will tell Indiana Jones the height of the staff so that when he takes it to a special map room, it'll reveal the location. Now, unfortunately, when he arrives in Egypt with Marion and the headpiece, he finds out that the Nazis have their own copy of the headpiece. Now, granted, their headpiece is a little bit rougher and only has writing on one side. As an audience member watching this movie, my heart sank. I thought, oh no, the bad guys are going to beat our heroes and to the Lost Ark. So Indy and his friend Sala go to an old wise man who's going to help them read the writing on the headpiece. And when he reads it, it says, make the staff 6 kadam high, which is about 6 feet tall. And then, or I don't know, 8 feet tall, however tall it is. And then we go, okay, so now we know how tall it is. But then he flips the headpiece over and he says, take 1 kadam back to honor the god whose ark this is. And it's at that moment the audience realizes probably the same thing that Indy and Sala realize, which is the bad guys are digging in the wrong place. And you might be asking yourself, well, why is Sid talking about Raiders of the Lost Ark today? Well, because if you have an API definition that is incomplete or has incorrect information, you're going to be digging in the wrong place. And today I want to help you avoid those pitfalls that you might encounter when using code generators with your API definition. So you could maybe title this talk OpenAPI and the SDK of Destiny if you wanted to. But we'll continue on this Indiana theme for a little bit longer. I just want to clarify for anyone who doesn't have a clear definition of what an SDK or software development kit is. The way we define it is it's a code library that developers would add to their project as a dependency, plus documentation that is specifically designed to teach the developer how to use that code library. It documents all the methods, all the models, how to authenticate, and it includes code samples for each of those methods so that it's really easy for the developer to understand how to use that code library to quickly integrate your API and get into production. So we could craft these software development kits, these code libraries. We could create these by hand, but there's a lot of benefits to generating them. And I thought I'd just touch on those before we continue with the talk today. First, having your API definition as your source of truth makes maintenance a lot easier. And what I mean by that is if you're generating documentation, like an API reference, right, that explains how to use your API, plus you're creating multiple SDKs in different languages like Python and Java and TypeScript and Ruby, right? Whenever you make a change to your API, you then need to go and update all those artifacts, all the documentation, all the code libraries, and all these languages. And doing that by hand, while it's possible, does introduce an opportunity to create, to introduce more bugs. It also takes a lot longer. So you can roll these changes out into multiple SDKs and into your documentation quite quickly. In fact, you can make the generating of your SDKs part of your whole CI/CD pipeline so that when you push a change to your API definition up into GitHub, it can kick off a process and it can generate all those artifacts for you. You're going to be more accurate. It's going to take you less time. And the engineers on your team can be deployed to build more APIs and new features instead of building those SDKs. So generating code to me is like a really big advantage for a company who's trying to scale up and connect with more developers and support more languages. Now, in order to begin on this journey, we need to have an API definition. And I'm sure a lot of people on this call might have an API definition, but for those who don't, I thought I would just touch on 3 different ways in which you can get started. The first way, and eventually like the way that you'll probably have to do a little bit of work, but everyone has their own workflows, I'll say, is to manually create this. There's a lot of tooling out there that can help. You might have a Postman collection. You might use a tool like Stoplight that has a nice visual editor to help you define all your paths and all the different objects for your requests and your responses and all the descriptions of these things and the examples of what a payload for a request body or response looks like. You can do all of that visually. You can also do it using an editor like Swagger Editor, where you're actually directly editing a YAML file or a JSON file. Everyone has their own preferences. I personally have found that YAML is a little bit easier to read. For me, JSON with all the curly braces and all the quotes around everything, I find I make more mistakes. So I've definitely leaning towards YAML when I am manually editing my API definition. A second way to do this, which I've seen at different places, is to add annotations into your actual code base for your API. So above each endpoint, you'll have some commented code that is designed to be read by a tool that can read those annotations and then generate an API definition for you. So there's ones in different languages like Go Swagger. And I've seen these used in practice to generate documentation. I haven't seen them used to generate code libraries. And therefore, I can't really vouch for whether they can get you all the way there and get you the high quality API definitions, but you might have that as a requirement at your company, and you might need to work through that to see if you can actually get that high quality API definition out for code generation. The third way is to actually use a tool like Optic or Treble to take your HTTP traffic and generate an API definition from that. And I would say this would probably give you the roughest API definition. They're going to try to infer the names of things. They're going to leave out a lot of the nice things. But if you're starting from zero and you're trying to get that first cut of your API definition, I don't think there's anything wrong with monitoring your API traffic and trying to get, 70% of it, 80% of it generated, and then pulling it into one of these tools to manually edit and complete your specification, or your definition, so it's ready and it's high quality, and you can start using it to generate documentation and code libraries. You also, some of you might be in a situation where you have not an OpenAPI 3 definition, but you've got your API definition in some other format. Let's say it's Swagger 2, it might be API Blueprint, RAML. You might have an Insomnia or Postman collection. Some of these formats are older. Depending on your age of your API and your company, you might have these available, and you want to get those to the latest, more modern version of an API definition like OpenAPI 3. There are tools for doing that, and APImatic has a free tool called API Transformer. So you can go sign up at apimatic.io, and you can do a one-time conversion, and it's free, doesn't cost you anything, and is a really nice way to get you closer to that well-written and up-to-date API definition. And why, you might ask, why do we need it to be in OpenAPI 3 or OpenAPI 3.1 or whatever it will become in the future? Because all the tools that you're going to want to use to generate artifacts have moved to OpenAPI or are moving to OpenAPI. So that's the direction everybody is going in, whether it's a product or an open source project. They're all have sort of coalesced around OpenAPI. Now, once you've got your API definition, along the way, you definitely have to validate this definition. I can't tell you how many times I worked in Swagger Editor and I didn't have my YAML file indented properly, or I omitted some key attribute to a component or to a path, and having it validate in real time was a real lifesaver and really helped me. So if you've got an existing API definition, you can copy and paste it right into Swagger Editor, and you can start editing and correcting those validation errors right inside the tool, and that's super nice. If you are more of a command line person, or you're making changes as part of a CI/CD pipeline and you're committing your spec to GitHub, you might want to do some validation before allowing that to be merged. And that's where a tool like Spectacle, which is an open source project built by Stoplight, can be really, really useful. It's got customizable rule sets, and you can use that to make sure your definition is really high quality. So now to the meat of our presentation. I'm going to dive into 5 pitfalls that you want to avoid when generating your SDKs. So like Indiana Jones, we want to avoid these pitfalls. So pitfall number 1 is omitting your operation IDs. Now, what is that? So if you define a path called pets and it's got an action of post, you need to have that post is an operation, and you have the opportunity to add a unique operation ID, and you can name it whatever you want. If you omit it, then what's going to happen with the code generators, depending on which one you're using, is it's going to try to infer what you want to call this method. As you can see in this case, it's taken our summary and it's just concatenated it all together and said, that's what we're going to call our method name. And you can imagine a developer using your SDK is not going to be very happy when they get these really long and complicated and not very intuitive method names. So instead of that, we can just add in an operation ID called update pet. And when we do that, it's going to take care of it for us. But if you use the same operation ID more than once, then again, you're going to get a weird method name. You'll get one method called update pet and one called update pet 1, for example. So the code generators try to not be blocked by any errors in your definition, but they will get unpredictable results if you don't have a really well-defined operation ID. So in this case, we have a unique operation ID called update pet. Our method is called update pet. The good thing about using Spectral with its standard rule set is that it will actually error out on a duplicate operation ID, and it will warn you if no operation ID is present. So listen to those warnings, don't ignore them, because it'll help you ensure that you're getting all those operation IDs set. A real quick tip for naming these: use a consistent pattern. I like to use like a verb plus the object or resource name, like update pet or create pet. Aim to be less than 30 characters and avoid using unnecessary stop words like the and. You also notice in my examples at the bottom, I have list pets because I'm actually getting an array of pets in that example. So use singular, plural to indicate whether the response is going to be an object or perhaps an array or a list. Pitfall number 2 that we want to avoid is omitting tags from operations. Now, I'm going to admit, when I first started working with OpenAPI definitions, I did not think tags were a big deal. I thought, use them, don't use them. In fact, I was working with a really large API with hundreds of endpoints or hundreds of operations, and I gave them all the same tag. And that didn't work out great because it put every single method inside of the same class. So tags are the way in which we can group our different methods into different files or classes. So here's a Java example. If I leave out the tags, then what it does is the code generator still works, but it throws everything into one class called API controller. And if I use tags in some methods, but leave out the tag in others, the ones that I use pets as my tag will be put in the pets controller. Everything else gets thrown into API controller. It makes it hard for developers when they're working in their IDE to type, API controller dot and getting the huge list of methods that are all unrelated to each other, just a mix and mashup of all these different methods. We want to collect them in a neat, tidy way so that similar methods are grouped together and easy for developers to access. So this is what it looks like in my API definition. I create a tags, I add an array, and I add pets. And I do that on every method. I get a nice controller called pets controller. Spectral, again, will warn me if I'm missing that tag property, which is great that Spectral does that for me. Here are just a few quick names, quick tips for naming your tags. Identify what that ideal grouping is for your methods. pluralize all your names unless it's like a singleton resource like settings, like it might be a setting, and you don't need to have, multiple, you don't have to have a plural name if it's just one setting endpoint, and aim to be less than 30 characters. Pitfall number 3, poorly written or no descriptions at all. Now, I think this might be one of the more challenging things for a developer, because developers sometimes aren't technical writers. They don't want to be coming up with, well-written creative description names. They want to get to the code. They want to move things as quickly as possible. But you really need to have descriptions on all of these following attributes of your API definition. At the very top, your info should have a description. Each tag should have a description. Each operation and parameter, the request body, the response content. And where I see descriptions fall off the most is probably on the schema, and each schema property needs to have a description. So when you're talking about a pet and there's a name for that pet, you need to have a description for that name property. So all the way down to the individual property on each object or each component. So what happens when we run Spectral? This is where things start to drop off. We do get an error for response content, and we do get some warnings for info, tag, operations, but we don't get any kind of alert that we've omitted our description for parameters, request body, schema, and all of those schema properties. So some tips for writing good descriptions. Make sure that you describe the element and mention any edge cases that may occur. And I personally feel like you should avoid short descriptions that don't add any value. A description about the list pets operation that just says list response, or response, like that's not really great description. It's not going to help when a developer reads that in their documentation. It may not help them when they're in their IDE and they're getting some hints around the use of this response or this method. But a description like a paged array of pets or a paged array of pet objects, however you want to phrase that, that's a much more informative and useful description for developers. Pitfall number 4, defining objects or enums in line. So this is definitely something that when I was starting out, I was guilty of. I was just cruising through my API definition, and I was just defining my schema objects right in line with my responses. And what that's going to do, if you follow that pattern, is you're going to get these oddly named classes being generated inside of your SDK. So in this case, this is actual API, what API-matic does. It kind of infers that this is the pets response. So it says, create a list of pets response. Not a great name, but I've seen worse. When I was at a previous company using OpenAPI generator, I got a lot of classes with names like inline response 200. So it didn't even look at the path that I was on. It just knew that it was an inline response and it was for a 200 response from an API. And I don't even know what endpoint it's for. I had to then go and figure out like where I'd define things in line by looking at the code that was generated and go back and forth with my definition and keep regenerating it to kind of figure things out. Because I was just starting out. I didn't know the rules or the pitfalls to avoid, and had a lot of heartache, a lot of time spent correcting all of those things. And again, if you have, let's say, a very similar object, a name like status, you might end up with status 1, status 2, status 3. You might end up with a lot of classes with very similar names that aren't very useful. And the reason the code generators do this, though, is because you can't have a class with a duplicate name in your file system. You're going to generate broken code. So don't blame the code generators. They're doing the best they can, and it's our job to give them the best instructions that we can. So if I create a reference to a schema component called pet, and I define that in my response, then it will use the name of my component. So it's a list of pet objects. And here you can see the code is what we would expect. Side benefit is that if I want to reference that pet object or pet component in any other part of my API definition, I can just point to it. And if I need to update that pet, I only have to update it in one place. So it follows a more dry, do not repeat yourself principle of API definitions. Sadly, Spectral is not going to catch any of these inline components, so you need to watch out for those pitfalls yourself. Tips for naming those objects in our schema. It's important use singular unless it represents some kind of collection of things, and don't prefix or postfix it. This is something I made this mistake. You might be tempted to call it a pet object or a status enum or something like that. Just keep it simple. Call it pet. That's all they need, because not that you're going to change it from an object to an array in the future, but it's not necessary to add that type information onto the name of the actual component that we're creating. And our fifth and final pitfall is forgetting to define our examples. And examples can show up in a lot of places. I know it's easy to think an example JSON response or an example request body. Yeah, that's probably the first kind of examples that we can create, but there's lots of other places that we need to define examples. So let's get into those. You should have examples of parameters that you're passing into methods. We talked about requests and responses. You also should have examples in those schema components that you define and examples for each property in your schema. So that's going to really help with your code that's being generated and any associated documentation. Here's an example of some docs that I generated where I didn't define any examples. And again, our code generators are going to do their best. For the ID, it decided to pick a random number, 120. And for the name, it came up with the not very intuitive name 6. Why name 6? Why the number 6? I don't know. Generators, they're a mystery sometimes. It generated this, and it didn't even know what my pet type was, so it didn't select one for me. If I define some good examples, though, as you see in this, we have given our dog the name Indiana, so that's good. It's got a real name that reflects our intention, and it's got a default pet of the dog. So you look on the left is our documentation, and on the right, we've got our code sample. So this would be some really good documentation to accompany any code libraries that we generate. And another benefit, if your code generator is API-matic, we will actually generate tests for each of your objects, your models, and we will use that the examples that you provide to generate those tests. Now, if you don't provide examples or they're incomplete, then we'll just skip and not create tests. But if they're there, we will. And so that's kind of a nice benefit. I don't think every code generator does this, but API-matic does. And again, sadly, I hope you don't feel like I'm beating up on Spectral. This is just their standard rule set. This isn't optimized for generating client SDKs. So again, they don't catch any missing examples for our API definition. But Spectral's an amazing tool. So, and I've got a little treat for everyone at the end of the talk to share with you. So you're really, really close to getting that prize, the thing that Indiana Jones desires, and that's a really high quality SDK. So you need to choose your code generator. I've been mentioning API-matic quite a bit. We have a SaaS product, and we generate SDKs in 7 different languages. So all the big ones: C#, Java, Ruby, TypeScript, Python, PHP, Go, and but we're not the only ones out there. There's lots of startups that are coming out there, and probably the biggest open source project in this space is OpenAPI Generator. I really recommend that you go out and you play around with these tools, you evaluate them, you compare the code, you compare the docs, you look at the code samples that they generate for you, and kind of how far does it get you? I've have experience with both API-matic and OpenAPI Generator at previous companies, so I can speak to those two. I can't really comment on the other startups that have come out the last year or so, but your mileage will definitely vary based on the tooling that you choose. So it's important to think about how much you have available for resources to dedicate to this project. And I've created, myself and some folks at API-matic, we've created a website called SDKs.io. And this is not a product per se, it's more of a place to educate and learn about building SDKs. What are some best practices to adhere to? What are some options for code generation? How do I compare and evaluate and get started with these different options? What's the different pros and cons to building versus buying a solution? And so this is all available. Go check it out when you have time. It's a great resource. We're going to keep enhancing and improving it. And if you have experiences building SDKs and you'd like to contribute, definitely reach out to me, and we can talk and maybe we can get you to help expand this resource for the community. Because when I went searching for how do you build a good SDK, I couldn't really find anything that was definitive. It was just a bunch of blog posts engineers have written after creating some SDKs at their company. So they're on Medium, they're on dev.to, they're just kind of all over the place, but there wasn't any one central resource. And so that's what we're looking to offer the community with this. And I mentioned I had something to share with you. So I decided as part of this project, I would see how hard is it to create my own custom rule set in Spectral. And so I went ahead and did that, and it's up on GitHub. It's still early in its development, but I've tested it quite a bit, and it does catch a lot of the descriptions and examples. If they're missing from your API definition, it'll warn you, and then it'll tell you where to go and correct those changes. So what does the rule set currently catch today, that custom Spectral rule set? It catches missing descriptions on parameters, request body, schemas, and schema properties. And it detects missing examples for parameters, request and response, schema, and schema properties. So it sort of fills in a lot of the gaps that you saw earlier in the presentation. And since I've got, I think, a little bit of time, I thought I'd just do a quick demo. This won't take long. I thought I would show you that I've got a little demo here. This is a real basic API definition. And if I come down into one of my parameters and I delete the description and save it, I can then go into my terminal. I've got Spectral running here. And inside of Spectral, I'm pointing to my little custom rule set. And if I run it, it tells me that my parameter must include a description. And it tells me that on line 92, I should go take a look. And here we are, 94, so that's close enough. And if I undo it and I save that change and then I run the same rule set, we didn't find any errors. So just wanted to show you that it works and prove that to y'all. And lastly, I just want to show just how a tool like API-matic works. Well, this is going to just take a minute to show you. I'll come in here. I will choose my demo API definition. I click import, and API-matic does its own validation. So even though you've done your validation using Spectral or some other tool, we're going to double check your work and make sure that everything is good. There's no errors in our definition, no warnings. I'll go ahead and hit proceed and then close it. And here's my new API definition. And when I go to generate it, it does one final check. And then it says, what do you want to generate? I can generate, individual SDKs, but I like to generate the whole portal. So what it's just done is it's created all my documentation as well as all of my libraries in all these different languages. So if I go into TypeScript, for example, then on the left side here, I've got get SDK. Now, when you go to production, you'll deploy it up to like NPM or Maven if you're using Java. But in this case, if I click Get SDK, it's going to download a zip file. And this tutorial actually tells me how to point to this zip file and install it as a dependency so I can actually evaluate and check out this code. And we talked about models and naming them properly. So here's our pet model, all nicely defined with an example of what it looks like. And we've got all our different methods. So if I choose, update pet, it gives me my example here. There's Indiana, the dog's name. Maybe Indiana is actually a cat. So if I change it to cat, you'll see on the right side, the code sample actually updates dynamically. And what I like most about API-matic is I can put in my API key. I can say show complete file. And then when I come here and click try it out, it actually goes and hits my mocking server and returns a response. And so that's what code generation can do for you. And with that, I will pause for any questions.
Hi, Sid. Thank you for your presentation. And it's time to have our QA. Unfortunately, Kundan will not be part of this QA. So if you have any question, any doubts, contact by LinkedIn. The LinkedIn appear on the agenda of this conference. So let's add to Deepa.
Hi.
Hi again, Deepa.
Hey, Sid, that was a great presentation.
Thank you very much. I appreciate you having me on today.
I have one question for you, Deepa.
Mm-hmm.
Do you consider that the best challenge or the most relevant challenge for Fugu is that not all the browsers have support from the different features? Because you mentioned on your presentation that not all the browsers have the same compatibility. So do you consider that that
yeah, it is, like I said, it is a challenge. It is, and more more browser vendors have to collaborate, and probably it is just starting. There are certain things most of these browser vendors support, and then they do not support on their either on their platforms. So it is a challenge for sure, and it does have puts engineers to at least try out new things and experiment. It's the whole idea of Project Fugu is to make sure that we open up more for the web, right? So that's something that I wanted to mention, and why not, right? But it all started with Web 2.0, but then it's everywhere it took up mobile, and then when I say native, it is not only mobile here, it's desktop, you have browsers. There's a lot of complexities that goes on around here, and not all APIs are intended for every single use case. And it depends on what does your application want, and probably there are some hardware APIs too that I did not mention a lot about them, but there is something for gamepad, joysticks, and stuff like that. So there are different APIs for different users. So different developers, they can probably check into the documentation and see. And if it is not there, they can also suggest. And there is a process for Project Fugu where you can go propose an idea or propose, but then they go through a review, and it is along with the Web3 as well. So that's something to consider.
Thanks for your answer. Sid, I have a question for you.
Okay.
What, in your opinion, what is the best way to track the changes in our definition of an API? If I can create like a file and create a separate repository and track all the changes, or just include in my microservices on my API, which is the best alternative to do this kind of things? Not big changes, just small. I think I add 2 or 3 attributes and nothing more.
Yeah. My experience is GitHub is a great place for your API definition to live. And there's even some integrations built with some tooling, like Swagger Editor can be authenticated and hooked up to a specific GitHub repo, so those changes get sent automatically. It's also a great opportunity if you have a team dedicated for overseeing your API governance, to implement some of those tooling to do a check of the change before it gets committed, and have a PR opportunity to review the pull requests. So we used to do that where the engineers would make the changes, but then our developer experience team would do a double check and make sure everything was properly formatted.
Thanks. And I have another question for you. You mentioned that the idea is add in the pipeline in CI/CD, like an extra step to validate all the rules. Do you consider that could be an option, add also in another pipeline, like run the regression test, mutation test, the things that are, okay, I deploy something and perhaps the rules change after that I deploy something? Do you consider that is could be a good option, that frequently validate if everything in my domain is okay or not, or just when I deploy something new?
Yeah, I think that it's probably good to have something I didn't touch upon, which is contract testing between your API, your actual live production API, and your definition. Your definition is only good if it actually reflects the reality of your API. So that, to me, is part of that entire pipeline, is to make sure that your definition is accurate in that regard, as well as valid, as well as it's been linted, and everything else that you would want to do as part of that process.
Thanks. And just one last question for Deepa, because I think we don't have a lot of time. In the case that our browser or the browser of the client not have support, do you recommend that we can add some behavior, that add default behavior to solve the problem, solve
this is something that
it's like not appear a big exception. It's like, okay, you don't have support or something like that, or just appear a model or something like that is more friendly for the user.
And the thing is, you have to also read the documentation. I just forgot to mention that there are some naming differences because Mac OS or the Safari browser has a different naming. So the web, there was a recent article that I read that Apple does support this API, but in a different way. You have to go look into the documentation and see whether you can customize it around. So I would personally say that if you are specifically targeting, Mac OS or particular platform, check into that documentation, because Microsoft has their own documentation as well. So personally, go check out the documentation. There might be subtle differences. There are different terminology differences, but this could probably be one of the things, but not all APIs are supported everywhere. So that's something that we wanted to unite these things together and probably have the best experience on that.
Yeah, I asked you a question because when HTML5 appears, I think the same problem appears, because not all the browsers have support to the same tags, and was so complicated. It's like include a lot of if in the source code, like if the browser is this, please add the default behavior using other tags or other annotations. When something new appear and need to have support to multiple browsers, a lot of problems appear.
Yeah, there is also one effort that's going on with Google is Project Baseline, where they want to bring both API, I think APIs, CSS, your JavaScript, probably trying to unite these things together across different browsers and bring the best out of it. But this is something different from that of Project Fugu. But there is an effort going on, and they just announced it during the Google I/O this year.
Thanks. I think we don't have more time. Thank you for your time, for your presentations. And it's time that Nick appeared to finish our day. So I will add to Nick.
Yeah,
Bye.
hi everybody. Yeah, thank you, Andres, for moderation. Thank you, Deepa and Sid, for joining today to present your knowledge. So thank you so much. I hope to see you in our upcoming events. Thank you.
Sounds good. Thank you so much, Nick, for having me here. I keep coming back here. I have something in September. We'll see you soon. Thank you.
Thanks, Nick. It was great. Appreciate it.
Bye. Yeah. Thank you.
Bye, Nick.
Bye.
Bye, Andres.
All right, so that is it for today's live stream. So that was just the junior track, the first day of the API forum. Tomorrow we have more sessions. We'll have senior track. We'll have more advanced topics, and you can go to check the agenda and be prepared on what topics to expect tomorrow. Definitely go check it out. This recording will be available right away, so I hope that you will rewatch something that you missed. But for now, thanks for joining, and I'll see you. I hope to see all of you tomorrow.